What is going on, everybody? My name is Bucky Roberts and welcome to your very first C++ tutorial. Now, my guess is that if you're watching this video, you probably already have a basic understanding of what C++ is. But for those of you guys who don't, C++ is a computer programming language. It's how you make computer programs, computer games. So if you're interested in making any of those, then congratulations, you're in the right spot. So before we just start opening any program and trying to write C++ code, I want to let you guys know that you need to download and install a few programs first. Now, good news, all these programs are entirely free. But before we just go ahead and start installing them, let me tell you guys what they are and what they do. The first program that you're going to need is called an IDE. This is pretty much the program that allows us to write the code and run it. Aside from that, we need something called a compiler. Now, a compiler is basically the thing that translates the code that something that computer programs can understand to something computers can understand. So, we're going to be typing code and it's going to be easy for us to read and understand what's going on, but in order to translate it to a bunch of ones and zeros that the computer can understand, we need that compiler. So with that being said, a lot of people download these separately. They download an IDE and then they download a compiler. But what I'm going to be doing is I'm going to be showing you guys a program that is going to allow you to download it and install it all in one big shebang. So let's go ahead and open Google, and like I said, don't worry about paying for anything because this program is entirely free. So anyways, like I said, go ahead and open Google and type in code blocks and go ahead and press enter. Now the first link that's going to pop up is probably going to be for codeblocks.org. So go ahead and click that, and this is the program that we're going to be downloading. So of course we need to find the download link. You can either click on this one on the left or this one on top, it doesn't matter. Go ahead and click on one of those and we see a couple options here. Download the binary release, download the source code, or retrieve source code from SVN. We're going to want to download the binary release. It's the easiest and most simple way to download this program, CodeBlocks. So go ahead and click download binary release and check it out. It gives us all these options. Now, depending on what platform you're running, most of you guys will probably be running Windows. You're going to want to choose one of these options. But for those of you running Linux, and they also have a Mac version down here, you might want to choose these. But for most of us, we're going to be running this on a Windows machine. So you're saying, alright, now we have it narrowed down to two choices, CodeBlocks 10.05 setup or CodeBlocks 10.05 MINGW setup. What we want to do is we want to download this second one, the one that says MINGW. Now this version 10.05 may be different depending on when you're watching this tutorial and if they updated CodeBlocks, but make sure you get the one that says MINGW. The first one is the IDE, the second one, MINGW, that MINGW means the compiler too. So when we download this, it's going to give us the IDE, and remember that's where we write the code, and the compiler as well. And remember, the compiler is the program we need so the computer can understand what we're doing. So go ahead and you can either download it from Barely OS or SourceForge. I already have it downloaded, so I'm not going to click this, but oh, excuse me, I got some phlegm in my throat. I just drank a Frutista Freeze from Taco Bell, and I ate a taco, and that is not a good idea because they should call these things brain freezes, brain freezies, because that's all it does to you. Just freezes your brain in your throat, and and it puts a bunch of phlegm in your throat, but I can't stop drinking it. It's addicting. So anyways, go ahead and click this link from sourceforge.net and go ahead and save the file. And whenever you save it and open it, a wizard's gonna pop up and you just have to click next like 80 different times and then you have CodeBlocks installed. So I already installed it, so I'm not gonna walk you guys through how to do that because it's really simple and I'm not gonna act like you guys are dumb and you don't know how to install things on your computer. So anyways, once you have it installed, you have this program called CodeBlocks right here. Now you probably have it on your all programs. You might have it under CodeBlocks. What I like to do is right click it and just send it to desktop. And what that's going to do is it's going to give you a nice little icon on your desktop. But anyways, Once you have it installed, just go ahead and double click it, and we're going to run a really simple program just to make sure it's working correctly. So go ahead, it gives you these tips, close them out. What we're going to want to do is create a new project, and you can either do that by creating this new project right here, but what I like to do is I like to go up to the file menu and click new project. Now it's going to give you a list of a bunch of different projects you're going to want to create. What we're going to want to choose is console application. This is what you're going to be choosing most of the time. This pretty much means a basic program for the computer. So just go ahead and select this and press go. And make sure you're working in C++. C is a totally different language. We don't want that. So C++, go ahead and click next. And now name your project anything you want. I'm going to name mine YouTube. Why not? And you can save it wherever you want. I might as well just save mine right on desktop. It looks good. But it really doesn't matter where you save it or even what you name your project. Just name it something that's easy to remember. So go ahead and give your project title. Go ahead and click next. And make sure you're using the GNU GCC compiler. Basically everything should be set up by default. Make sure your settings look the same as mine. As long as you didn't hit anything by accident, you should be good to go. So go ahead and click finish, and you see that nothing pops up by default. And you're saying, alright, I thought we just created something, so how do we see what we just created? Actually, if you click this little plus sign next to sources, it shows you that all the files it created for you automatically. So go ahead and double click this main CPP, and it shows you, or in other words, it brings up the file that it created automatically. So this is actually the core basics of a very simple C++ program. We don't understand what anything means right now, but trust me, it's a very simple computer program that the only thing it does is it prints out hello world on the screen. So to make sure that everything is set up and running smoothly, let's go ahead and we need to do something called build and run this. Now I'm going to be talking about this later, but for now I just want to make sure that your computer is set up, you installed it and downloaded it properly. So go ahead and click this build and run icon right here. It's with the little gear and the little green triangle. So go ahead and click that, and it should, maybe flash a couple boxes. But basically, a box should pop up that says Hello World. And this is all that that program is. Basically, it prints out Hello World on your screen. So if you build and run this and you get Hello World, it means that you downloaded it, installed it, and set up your project successfully. So we are good to go. So again, I know you guys don't know what any of this means or even know how to code one line of code yet, but I'm going to be going over that in the future tutorials. But for now, that's all I have for you guys. So thank you very much for watching. Don't forget to subscribe, and I'll see you next tutorial. What is going on, guys? It's Bucky, and welcome to your second C++ tutorial. And in this tutorial, what I'm going to be doing is I'm going to be breaking apart this computer program that we ran in the last tutorial. So if you remember, whenever we first created a project in CodeBlocks, CodeBlocks already made a very simple computer program for us to run and test out just to make sure everything was working. And all it did was it printed out Hello World on the screen. So if you go ahead and build and run this, we see that it just says Hello World and some other computer stuff that isn't really relevant. But anyways, all this computer program does is print out Hello World. And before I get into breaking this apart and telling you what each piece does, I want to say one thing. You would think, since computer programs are just made up of a bunch of lines of text, that we can learn each line one at a time. But computer programs are weird in that this is pretty much the most simple program you can write. And check it out. There are already 7 different lines included here. So in order to even write a most basic program, you need to code at least 7 lines of code. So it seems kind of confusing, and I just want to give you guys a warning. As long as you can get through this video, all the rest of the videos are going to be incredibly easy. This is the only one where I have to throw a bunch of information at you, but still I'm going to break it down as easy as possible. And the reason for that is because you need so many things in order to run such a simple program, but once you understand the basics, everything else is just smooth sailing, I promise. So let me go ahead, and we're going to be getting more in depth in each of these lines, but for now, let me just give you guys a brief introduction to what each line does. Let's go ahead and start at the top and work our way down. This include IOStream line right here, This is technically called a preprocessor directive. So if you're taking a test, if you're watching these tutorials because, maybe you're in C++ class and your teacher's kind of confusing you, answer on the test, this is a preprocessor directive. Now, what that means in everyday terms is it pretty much says, all right, we're going to be including a file in this program that we're going to be using later on. So it's going to be including a file, IO stream, that we didn't make. We didn't make this file, but it needs it to run this program later on. So that's why it needed to include it. Again, we're going to be talking more about header files later on, but for the basics of this tutorial, all you need is to know that this line includes a file that our program needs to use later on. Now, the next line you can see is just a blank line. And you may say, alright, do you need this blank line? Do you not need it? Blank lines and spaces, you can have a million of them if you want, or you can have none of them, just like that. All blank lines do in programming is they make the program easier to read. Just with a book or a magazine or a newspaper, sometimes you want blank lines between your code. Sometimes you just want your code right under each other. It's personal preference. People, whatever you want. Blank lines just make it easier to read, so whatever is easier for you, add as many lines or as less lines as you want. And that brings me to another point. These tabs, too, see this is kind of tabbed out or tabbed in. It's the same thing. Some people tab things in, make it easier to read. This program is just going to run just fine if it's just like that. But, people just like to line certain things up. So you'll see later on once we get coding that tabs and spaces and blank lines, they don't really mean anything significant. They just make the program easier to read. So that being said, under that blank line is this using namespace STD. And believe it or not, this does not stand for sexually transmitted disease. I like to think that, but trust me, it doesn't. It stands for the standard library. And that's another thing that is built in to C++ that is pretty much saying this. We're going to be using all the standard things with C++, nothing fancy. Again, we're going to be going over libraries and stuff in the future, but basically these two lines include things that we're going to need later on. This includes a file, and this includes something called a library, which, is just a bunch of C++ stuff. So with that being said, we know that these two lines include things. Fair enough. So now let's get to the meat and I don't know, meat and potatoes, I guess, of the computer programming, and that's this. This entire thing is called a function. Now, all computer programs are made up of functions, and all functions are things you want the computer to do. For example, whenever we're making programs later on, we're going to make a function to play sounds, and we're going to make a function to draw graphics on the screen. And as you can see, functions are just things that you want the computer to do. So every computer program starts with a function called main. This is how your computer knows where to start. So for example, in a couple tutorials we're going to have a function called main, and like I said, we're going to have another function called play a sound, and we're going to have another function called make a ball bounce around on the screen. And you're going to have all these functions, and your computer's going to say, alright, you gave me all this stuff to do, but how do I know what order to do them in? Well, your computer automatically knows anytime it runs a program to start with the main function. So that's why it's so crucial to name this function main. So in order to make a function, you do this. You first write what type of data you're going to be working with. And what functions typically do is they do some sort of calculations. For example, find the body mass index or calculate the velocity of something. Well, whenever it makes this calculation, it usually wants a number back, an answer in other words. Well, since we're going to be working with just integers, main always works with integers, so that's why we need that. But again, we'll be getting into that later on. After that is the name of the function, and this one is named main. Don't worry about these parentheses right now, but what we do need to worry about is these little, they're not semicolons, squiggly brackets, I guess they're called, curly braces, I don't know, whatever the heck they are. And this has an opening and a closing curly brace, and in between them you have something called statements. Now all functions are made up of statements, and all statements are basically instructions, and each instruction needs to end with a semicolon. That's why you see every line inside a function ends with a semicolon. For example, if you had a function that says make a peanut butter and jelly sandwich, one statement would be get out the bread. The next statement would be put butter on a piece of bread. The next statement would be put jelly on a piece of bread. The next, put them together. The last, put them in your mouth. Bam. You now have a function and a series of statements. Well, all this function did, the main one said, print out something on the screen and return 0. Simple enough. So now you can see the basics of a function, how they're made, and how every function needs to include statements or instructions. So that being said, let's break this down even more. The first statement is saying this. First of all, the C out thing right here, that's called an output stream object. And it's basically used to write characters on the computer screen. That's how we are able to type hello world on the computer screen. So this is always used in conjunction with this. This is called the stream insertion operator. This pretty much takes all the stuff to the right of it and prints it out on the screen. I mean, this is just, it's weird symbols, but that's whoever made C++, they decided to use these weird symbols to print out something on the screen. Why they did, I don't know. You have to take it up with them. But anyways, this is basically how you print out stuff in the screen. So this prints out hello world, and then this pretty much just means end line or go to the next line. So this line right here is pretty much just saying print something out on the screen. Now this last thing I want to talk to you guys about is called the return statement. Now usually, like I said, functions will calculate something like body mass index or velocity, and when they calculate it, it's going to want an answer back. So if I had a function that calculated my weight, it would return 155 or 160 depending on if I ate tacos or not today. Well, the main function should always have return 0, and return 0 means whenever you return 0, it tells your program that it ran fine without any errors. For example, if you had a bunch of extra text right here, your computer program would give you an error and it would never get to this line right here, so it would never return 0. So whenever it does get to this line, it means everything above it ran fine, and return 0 means you are good to go, main ran fine. So I know that was a lot of information to give to you guys for just your first tutorial. But again, like I said, every computer program starts with a bunch of stuff that you need to know, and we're going to be covering each more of these topics in depth, but for now I just want to give you guys a basic understanding of how a computer program is made. So if you don't understand everything completely, then don't worry, you're not alone. You will in the future, I promise. But for now, thank you for sticking with me, and thank you for watching this tutorial, and I can't wait to see you in the next tutorial. And if you have any questions, don't forget to check out my website, thenewboston.com, and yeah, I'll see you in the next video. What is going on, guys? It's Bucky, and welcome to your third C++ tutorial. And in this tutorial, I want to go over a little more about printing text out on the screen. Now, in the last tutorial, you remember that we could use that special thing called cout, which was technically called the output object, and the less than sign, which was called the stream insertion operator, to print out text on the screen. And the way we did this is we added double quotes after, and whatever we printed out in these double quotes, like boy, I love bacon, whatever we put inside those double quotes would just print out on the screen. So if we go ahead and we built and run this, we saw boy, I love bacon right on the screen. Simple enough. But now what I want to go over is just a little more about cout, and I just want to make sure you guys understand how it works. So each function is made up of these things called statements, and typically people put one statement per line of code. And remember, all statements end with semicolons. So say we wanted to print out something else out on the screen. Well, you'd write cout less than, and write something else like and ham, just like that. So you might be thinking, alright, I got a feeling I know what this is going to do. On the first line, it's going to print out boy, I love bacon. And on the second line, it's going to print out and ham because, that's how it appears in our code. So that's what it's going to do. But if you go ahead and build and run this, it says boy, I love bacon and ham, all on the same line of code. And if you're scratching your head saying, alright, why exactly does it do that? The reason it does that is because when you're using this thing called cout, it's called printing it out into a stream, and it pretty much takes all your characters and prints them out in the same stream. So whenever this stream is done, you're not telling it to move to a new line. You're just saying print out these characters and then stop right at the end of this line. So then this stream starts printing out, and again, you're not telling it anywhere to move to a new line. computer programs are very picky and they need to be told exactly what to do. So in order to move to a new line, we need to add a special symbol, I guess you would say. And the symbol is this. First of all, you need to add another stream insertion operator, and you can go ahead and write ENDL. What this means is end line. And now, when we go ahead and build and run it, check what happens. It runs boy I love bacon, and then it runs end line. And before, your stream insertion operator would be right here, but now since you said end line, it go ahead and it ends this line and it moves it to a next line. So basically all you have to remember is anytime you want to move to a new line, use the character end L, which is code word for end line. Now if you're saying, alright, that's easy enough to remember, so let me go ahead and show you something that might be even easier for you. Inside your quotation marks, if you go ahead and add \n, this is basically the same as adding a new line. \n is the code, I guess that all is code, for go to a new line. So now it's going to say boy I love bacon, and then it's going to come across this thing called \n. It's going to say, hold on, what is this \n? Oh, I know what it is. It's the symbol to move to a new line. So this is basically just an alternative way to move to new lines. The only difference is when NL, you needed to add another insertion operator and then write NL right there. With a new line, you write it inside the quotation marks because it gets interpreted in a different kind of way. So let's go ahead and build and run this and just verify that, yep, boy I love bacon, new line, and ham. So again, like I said, whenever you want to print text out on a new line, you have to be very specific with C++ and tell it exactly what to do. And you can do this either using the NL or the new line that goes inside the quotation marks. So aside from this, you might be thinking, alright, so I printed this out and I got this on the next line, but what if I wanted a blank line in between these two? Well, all you would have to do is write new line, and then when you go ahead and you build and run this, it will say, alright, boy I love bacon, new line, and then it printed out and ham. Simple enough. Pretty cool, huh? And I guess one other thing I can show you is if you go ahead and do cout insertion operator, you can do things like this. Boy, new line, I, new line, love, new line, bacon, new line. So, you're not only limited to, one new line per statement. You can have multiple new lines in a single statement. So now it says, boy, I love bacon. Pretty cool, huh? So that's all the basics I want to teach you guys for this tutorial. Again, I wanted to stress how to print out text on the screen, and also the stream insertion operator. It's basically this. Each stream insertion resumes its printing out wherever the previous one stopped. So if you want to move it to a new line, you need to use one of these new line symbols, either NL or new line. So that's all I have for you guys in this tutorial. Now you should be a pro at printing text out on the screen. So we're not ready to bundle up this program and sell it to Microsoft yet, but hey, it's a start. So thank you guys for watching. If you have any questions, go to my website, thenewboston.com, and ask me on my forum. So thank you guys for watching, and I guess I'll see you in the next video. What is going on, guys? Welcome back to your fourth C++ tutorial, and in this tutorial I'm going to be going over something called variables, because variables are such a huge part of C++. I can't stress this enough. So let's go ahead and tap into our memory banks and try to remember back in like 7th grade when you first started learning about variables. And if you can't remember, let me give you a brief history lesson. Variables are basically just placeholders. That's all they are. So let's go ahead and say we had a variable named x and we set it equal to bacon. Well then, whenever we would have a sentence like Bucky loves x, we knew that x equals bacon, so this meant Bucky loves bacon. Simple enough. So let me give you guys another quick example. Say x was equal to 7. So then when we had a statement like 5 plus x, we knew that this meant 5 plus 7. Simple enough. So as you can see, a variable is basically just a placeholder. Now, let me go ahead and show you guys how to make variables in C++. In C++, in order to make variables, you go ahead and first write the type of variable you're going to be working with. Now, I'm going to be going over data types later, but for now, I want to give you guys one data type, and that's int. This stands for integer, and an integer is pretty much like a whole number like 6, 83, 540. It's a number without a decimal place. So now that you gave C++ the type of data you're going to be working with, you need to go ahead and name your variable. Go ahead and name it anything you want. I'm going to go ahead and name mine tuna. So now it has a type and a name. So now all we have to do is use the equal sign and set it equal to a value. So since this has to be equal to a whole number, let's set it equal to 6. It doesn't matter what whole number you set equal to, but I just like 6. It's easy to type. So now we have the variable tuna, and C++ knows that it's an integer and it's equal to the value of 6. So now what can we do with variables? Well, just like we can print out text on the screen, we can also print out variables just as easy. So if you went ahead and said cout and just go ahead and print it out tuna, we can go ahead and build and run this, and it would print out not the word tuna, but it would print out 6, just like that. So that's pretty cool, and that's the basics of variables and how we can use variables in C++. And actually, in this tutorial, what I was planning on doing is building a simple calculator. Let me go ahead, and I guess I have time for this. Let's go ahead and make two variables, and I'll show you guys another cool thing that you can do with C++. Let's go ahead and make int. Make a variable called a, and we'll set it equal to 4. Let's go ahead and make another variable called b, which is of course an integer because that's the only type we know right now, and we'll set this equal to 21 or something. Doesn't matter as long as they're both numbers. Now let's go ahead and make another variable called sum, and this sum is going to be equal to a plus b. So now you can see, aside from, well, let's go ahead and, yeah, that's good enough. So now you can see that aside from just assigning variables numbers just like that, you can also use basic arithmetic to set variables equal to another value as well. So now the value of 25, a plus b, is going to be equal to sum. So now if you go ahead and print out cout sum, and then we go ahead and we build and run this, check it out. It prints out 25 on the screen. Pretty cool, huh? So again, in this tutorial, I want to show you guys that in order to make variables, go ahead and write the data type, what do you want the name of the variable, or excuse me, what you want the name of the variable to be, and what you want the value of the variable to be. And then, aside from just assigning variables basic values, you can also use basic arithmetic like a plus b, b minus a. You could have done that. Let's see, if you had b minus a, let's go ahead and see what the value of that is. 17. So again, you can go ahead and set variables equal to basic arithmetic using other variables, and you can even do this. Sum equals 48 minus 7. Again, this isn't really the sum anymore. It's more of a what is it? Not the product, not the quotient, the difference. There we go. That's what and there we go. I got it. So again, you understand the basics of variables. That's what I'm trying to stress. So in the next tutorial, what I'm going to be doing is I'm going to be showing you guys how to make a very basic calculator. And this is the first program we're going to be building that actually interacts with the user. And it's going to be awesome. And you needed to understand variables before I could show that to you guys. So that's why I had to go over this tutorial. But for now, thank you guys for watching. Don't forget to subscribe. And don't forget to check out my website, thenewboston.com. It's awesome. So anyways, thank you guys for watching, and I'll see you next video. Alright guys, welcome back to your 5th C++ tutorial, and in this tutorial, since we now have the knowledge of variables within C++, let's put that knowledge to use. So let's go ahead and make 3 variables right now, but I'm going to be making them a little bit different than before. So in the last tutorial, we had a variable like a, and you set it equal to a value like 54. Simple enough. But I want to tell you guys that whenever you first create a variable, you have the option of assigning the value then or assigning the value later on, such as a equals 54. This is perfectly fine, and you can do it this way. So whenever you first create a variable and you don't assign the value, this is called declaring the variable. Declaring is just another name for creating the variable. So let's go ahead and create 3 variables. And by the way, I'm going to be making a basic computer program where the user enters 2 numbers such as like 2 and 3, and the computer is going to add them together and it's going to give them the answer, which would be 5. So int a, I'm going to have a variable called a, and I'm going to have another variable called b. And what we're going to be doing is we're going to be calculating the sum, or in other words, when you add the 2 numbers together, the answer of that, and storing it in a variable called sum. So we don't have any of the values yet, so that's why we can't fill them in. The user is going to be entering the values for us. So the first thing we want to make in this program is just a little prompt on the screen to tell the user to enter a number. And we do that using cout, and we just write enter a number, Haas. And then let's go ahead and write new line. And now we need a way for the user actually to input information from their keyboard. So here's a neat little thing I can tell you. Cout took information from your computer and output it to the screen. But anytime you want to take information from the computer, or excuse me, from the user and give it to the computer, you need to use cin. So cout basically takes information from the computer and gives it to the user. Cin takes information from the user and gives it to the computer. So if you write cin, and by the way, if you're taking a test, this is technically called the input stream object. And the little greater than sign is called the stream extraction operator. So, make sure to fill that out on your multiple choice if you're watching this in a C++ class or something. So anyways, you can see that this is different from the cout for 2 reasons. First of all, it's cin instead of cout, and also your arrows face the opposite way. That's because you're giving information to the computer instead of the computer giving information to you. So now what we can do is we're going to enter a number, and whatever number we enter, we need to give it a place to store that number. Well, we already have a variable right here, so let's go ahead and use that and use the variable a. So check this out. It's going to allow us to enter a number, and whatever number we enter, it's going to be stored in the variable a. So for example, if we enter the number 3, a is going to be equal to 3. Simple enough. So now that we have that variable taken care of, we basically need to do the same thing again with the other variable b. So cout, we'll say enter another number, and just go ahead and we'll just make a new line to make the program easier to read, and use that cin again. But now when they enter a number, we want that value to be equal to the variable b. So they're going to enter 2 numbers. One's going to be equal to a, the other is going to be equal to b. So now for the sum, we don't want them to enter a value for the sum. We want to calculate that ourselves. So in order to do that, just go ahead and write sum equals a plus b. And now what our computer program is going to do is it's going to say, all right, I'm going to grab the value you put in for a, and I'm going to grab the value you put in for b, and I'm going to calculate that, and I'm going to store that in the variable sum. So for example, if you wrote 10 and 15, it's going to say, all right, grab 10, grab 15, calculate the sum of it, which is 25, and store it in a variable called sum. So now the sum is equal to the answer, and all we have to do now is print it out on the screen. So cout, we'll just write the sum of those numbers is it the sum of those numbers are, or sum of those numbers is? I think it's is because it's one sum. And again, anytime you want to add more than one line of text, you could do it like this. You could write a new line and then print this out on another line, but I want to add it on the same line. So I'm going to go ahead and add another insertion operator just like that, and just go ahead and write sum. And then add another one and just go ahead and write end line, just so our program looks nice and neat. So basically, well, let me go ahead and run this, and I'll talk you guys through it after I run it. Our computer program says enter a number, Haas. I'm going to enter 50 and then go ahead and press enter. Once I press enter, 50 is going to be stored in the variable a. It says enter another number. I'm going to enter 32. Then I'm going to press enter, and that 32 is going to be stored in the variable b. Then it's going to make our calculation and print it out on the screen. The sum of those numbers is 82. 50 plus 32 is indeed 82. So remember, what we did is basically this. We made three variables that we're going to be using later on. The first thing it said is just basically a prompt. Enter a number. Then we entered 50. It stored 50 in the variable a using cin. Again, cin is a way that the user can give information to the computer program instead of the other way around. So now a is equal to 50. It gave us another prompt and we typed in 32. Now b is equal to 32. So in order to calculate the sum, we took the sum variable and set it equal to the sum of 50 plus 32. So now sum holds the value of 82 or 83, whatever I typed in, I can't remember. And then all we did is we printed it out on the screen. And again, we could have wrote three different statements for this. One C out for this, one C out for this, one C out for this. But in order to save us some time, we can actually use this operator right here and print everything out on one line. So that is why our program ran the way it did. Again, let's just go ahead and run it one more time. Enter a number, 44 and 76, hit enter. The sum of those numbers is 120. Pretty cool, huh? So that's how you build a basic calculator in C++ using variables and cout. So now that you got that done, we can begin moving on to the next topic, which is I don't know. But trust me, it's going to be amazing. So you study this, and once you understand the basics of variables and cin, you're ready to move on to the next video. So for now, thank you guys for watching. Don't forget to subscribe, and I will see you in the next tutorial. What is going on, guys? It's Bucky, and welcome to your 6th C++ tutorial. And in this tutorial, I want to go over some concepts with variables that are definitely going to help you later on. So the first thing I want to go over is this. You remember in the last tutorial where I told you guys that there are basically two different ways to create variables. The first way is to create a variable called tuna or something and set it equal to a value like 43 all on one line. Simple enough, easy to understand. Well, what I also told you guys you can do is you can declare, aka create it on one line and set it equal to a value on another line, such as that. They're both perfectly acceptable ways to do things. The one thing I wanted to stress is that whenever you do this way, declare it on one line and set it equal to a value on another line, you don't need to write what type of variable it is again. Once you give C++ the information of what type of data you're working with, you don't need to list it every time you're working with a variable. C++ will remember that information and, it'll keep it. So whenever you're working with tuna later on, you don't need to explicitly write int, and actually you can't, or else it'll give you an error message. So just make sure that, just remember that don't write int twice on the same variable. So aside from that, let me show you guys this. Int tuna equals 99. So later on, and I didn't tell you guys this, but what you can do is if you set tuna equal to something else, like 76, whenever your computer creates a variable, it sets aside a piece of memory to store that value, in this case 99. Well, whenever you whenever you use that variable again and set it equal to a new value, what your computer is going to do is it's going to wipe out the old value in order to make room for the new value. So now you said, alright, we have a variable called tuna and that's equal to 99. Well, now we have a variable called tuna and we want to set this equal to 76. Well, alright, so we're going to try to print out tuna, and our computer is going to say, alright, should I print out 99 or 76? Well, since we created one originally that was 99 and then we overrode it to make it 76, it's going to print out 76. So let's go ahead and build and run this and see what we get. 76. So basically, whenever you have a value, it's placed in a memory location, and then whenever you give that variable a new value, it's going to overwrite the old value and put it in the same location. So I just want to tell you guys that this is how you can overwrite variables. So if you're expecting 99 and you got 76, this is why. So that's actually all I have for you guys for this tutorial. Again, the two things I want to stress is whenever you're creating a variable, you only write the type once. You don't need to write it every single time. And then whenever you need to reassign a value, you just go ahead and write the variable name and not the type again. And also, whenever you're overwriting a variable, you use the variable and it's going to be equal to the latest value. So whenever you set this equal to 76, it's going to wipe out the 99 and use the 76. So I just wanted to stress those, a couple of memory concepts, so then whenever we're building programs later on, you might have a better understanding of how it works. So for now, that's all I have for you guys. In the next tutorial, you know how I said that we're going to be going over arithmetic, like how to add two numbers together? Well, there's actually a bunch of different arithmetic operators that we need to learn, and that's what we're going to be covering in the next tutorial. But for now, thank you guys for watching. Don't forget to subscribe, and I'll see you in the next video. Alrighty guys, welcome back to your 7th C++ tutorial, and in this tutorial, as promised, I'm going to be going over basic C++ arithmetic. Now, I don't know, I think it was like 2 tutorials ago, I gave you guys a variable and I showed you guys that instead of just setting it equal to a plain old value like this, you can use basic arithmetic like 4 plus 6. And then when you go ahead and you print it out X or anything like that, it actually calculated the value and printed out the answer. So go ahead and run this and you see that X now equals 10, 4 plus 6. So aside from addition, I want to show you guys all the arithmetic operators that you can use, and they're a little bit different than you might expect. So let's start with the easy ones first. The first one is subtraction, and of course, like 8 minus 4, this would be valid. If we go ahead and build this, we saw that the answer would be 4. So addition, subtraction, easy enough. But also, aside from addition and subtraction, you can use multiplication. But make sure not to use X like that, because that'll mess up. In order to multiply in computer programming, you use the asterisk, and that's the symbol above the 8 on your keyboard. And what this is going to do is multiply these two numbers, 8 times 4. So now if you go ahead and run this, we should get 32, and check it out, 32, just like that. So well, let's go ahead and before I go over this, let's go ahead and go over division. In order to use division in computer programming, let's go ahead and take 81 divided by 3. Division, the symbol for this is the /. So let's go ahead and take 81 divided by 3 and we get 27, just like that. Simple enough. But check this out. What if we have something like 81 divided by 2? Well, it should be 40, but it has a remainder of 1. So let's go ahead and try to build and run this and see what we get. Well, it just says 40, and that's not entirely right because it should have a remainder of 1 with it. So we're saying, alright, we're working with integers right here, and we don't know any other data types, so how can we get that remainder? Well, whenever we want to use the remainder, we need to use something called the modulus operator, and that is the percent sign like this. What this is going to do is it's going to give you the remainder of the answer. It's not going to say 40 remainder 1. It's just going to give you that 1. So let's go ahead and build and run this, and you can see that whenever we do 81 modulus 2, it's going to give us the remainder, which is 1. So let me show you guys a better example, maybe 24 modulus 7. Well, we know that 24 divided by 7 is 3 with a remainder of 3. So let's go ahead and build this, and again, it doesn't say 3 remainder 3. It just says the remainder, which is 3. Simple enough. So now that we know all the arithmetic operators, I can begin teaching guys about order of precedence. Now, aside from just, one number arithmetic operator, another number, you can have complex calculations like 6 times 4 plus 8 times 4 plus 9 divided by 20. And if we go ahead and build and run this, let's see what we get. 56. We're saying, alright, so what order is this doing this in? Is it doing 6 times 4 and then plus 8? Or is it doing, 4 plus 8 and then times that by 6? Because depending on how you do it, it's going to come out with a different result. So the basics is this. If you remember way back in like 7th grade math, you know something called your associative property, and that's pretty much this. Anything that's in parentheses gets done first. If you don't have any parentheses, it goes like this. It does all the multiplication and division, which would be this, this, and this. It's going to do that first, and then it's going to do your addition and subtraction. If you don't have, if if you just have like 4 plus 8 plus 7, you're saying, all right, then is it going to do 8 plus 7 first or 4 plus 8 first? It really doesn't matter. It comes out the same either way. The only time you have varying answers is when you have like 4 plus 3 times 7. For example, if you did 4 plus 3, it would be 7 times 7 would be 49. But whenever we run this, whoa, easy box, we get 25. Why is that? Because it uses the associative property. It actually multiplies first, which is 7 times 3, and that's 21 plus 4, which is 25. So again, if you want to explicitly say 4 plus 3 first, you need to surround that in parentheses. So now whenever we build and run this, it's going to run your parentheses first and say, alright, 4 plus 3 equals 7 times 7 equals 49. So remember, the rule is this: parentheses first, then your multiplication and division, and then your addition and subtraction. So remember that, and if you get confused, it's called the associative property. You should have learned it in like 8th grade math or 9th grade math or maybe 7th grade. I don't know. I can't remember. It was a long time ago. For now, that's all I want to talk to you guys about. Basic arithmetic and how it works in C++. So for now, that's all you guys get. So thank you guys for watching this tutorial. If you have any questions, go to my website, thenewboston.com, and click on forum, and you can ask me there. So one last time, thank you guys for watching. Don't forget to subscribe, and I'll see you next video. What is up, guys? It is Bucky, and welcome to your 8th C++ tutorial. And in this tutorial, I want to talk to you guys about something called the if statement. Now, the if statement is a way where we can have our program make very basic decisions. What we're going to be doing is we're going to be giving our computer program a test, and it's going to run that test. If the test is true, then it's going to run a certain bit of code. If the test is false, then it's not going to run any bit of code. So depending on that test depends whether we run code or not. So it sounds confusing, but it's actually incredibly simple. So let me go ahead and I'll show you the syntax for if statement right now. The syntax to make an if statement is if. You just go ahead and type the word f, and then go ahead and add parentheses. Now inside our parentheses is where we're going to be making our test. Now after those parentheses, go ahead and add curly braces. Now this is called the body of the if statement, and now here is where we write the code to run if the test is true. So let's go ahead and make a simple bit of code. Let's go ahead and just write like cout Bucky is awesome. So if our test is true, it's going to print out Bucky is awesome on the screen. If the test is false, it's not going to print out anything. So let's go ahead and let me talk to you guys about the different types of tests. The first test I want to show you guys is the greater than test. And this simply tests if one value is greater than another value. So if 5 is greater than 3, go ahead and run this code. So 5 is indeed greater than 3. So this is true. So whenever we build and run this, it's going to say Bucky is awesome. Pretty cool, huh? So now let's go ahead and make something like is 1 greater than 3? So it's going to test this. Is 1 greater than 3? Well, this is actually false. 1 is less than 3, so it's not going to run this bit of code. So go ahead, build and run this, and as you can see, it did not print out Bucky is awesome on the screen. How sad. So of course we have the greater than test. We obviously have the less than test. 1 less than 3. Well, now this is going to be true, so it's going to print out Bucky is awesome on the screen. So let's go ahead and run this, and indeed it prints out Bucky is awesome. So aside from greater than and less than, we also have these two tests, greater than or equals to. So whenever we tested whether 3 is greater than 3, this test is going to be false because 3 is not greater than 3. 3 is actually equal to 3. Well, if we want to test if 3 is greater than or equal to 3, we use greater than with the equal sign after it. So now whenever we run it, is 3 greater than or equal to 3? Yes, 3 is equal to 3. So it printed out Bucky is awesome. So aside from that, we also have the less than or equal to. So if, is 1 less than or equal to 3? Yes, 1 is less than 3, so it's going to print out Bucky is awesome. So again, what I want to show you guys is that you have greater than, less than, greater than or equals to, and less than or equals to. So now those are called the relational operators. We also have two more tests that we can do, and these are called the equality operators. This is a really simple test. It tests whether one value is equal to another value or if one value is not equal to another value. So in order to do this, go ahead and write is 3 equal to 3. And you might be thinking, alright, why don't I just use one equal sign? Why didn't they make it that way? Well, whenever we were creating variables, such as like int x equals 8, the one equal sign, the single equal sign, is a sign for creating variables and assigning values. So that's why they decided that two equal signs was sufficient for testing. So remember, a common mistake is to put one equal sign in there and you're going to get an error or something terrible is going to happen. So whenever you're testing, you need two equal signs. So let's go ahead and run this test. Is 3 equal to 3? Well, yes it is, so it's going to print out Bucky is awesome. Give it another test, like is 7 equal to 3? Well, no it's not, so it's not going to print out Bucky is awesome. So that is one test. It's called the equal sign, or equal to test. And there's one more test I want to go over, and that's exclamation point equal sign. And this is the keyword for not equals to. So is 8 not equal to, or in other words, is 8 different than 8? Well, no, it's the same, so it's not going to print out everything. Is 10 different than 8? Well, yes it is, so that's going to be true, and it's going to print out Bucky is awesome. So that is all the tests that I have for you guys, and that's all the tests in C++. Again, to recap one last time: greater than, less than, greater than or equal to, less than or equal to, equal, and not equal. So now that we know all those tests, I probably should tell you guys this. People typically don't, and by people I mean computer programmers typically don't just test two numbers against each other. They usually have variables that they test against each other, like int a equals 98, int b equals 76, and then they test something like is a greater than b. Well, if we go ahead and run this, 98 is indeed greater than 76, so of course that's true. It's going to print out Bucky is awesome. And aside from that, you either have two variables to test, or you have a variable and a value, like is 98 greater than 5, something like that. We can actually mix variables with values, and that would be true as well. So again, you can either have two values in here, two variables, or a variable on one side and value on another side. Pretty cool, huh? So that's the basics of, again, relational operators are the greater than and less than one, and equality operators are the equals equals and exclamation point equals. So now that we know how to make a basic if statement, again to recap one last time: if your test and then the body, and it's going to run the test, and if that code is true, it's going to run the body. That's the basics of an if statement. Now that we understand that, we can begin enhancing our programs a little bit more. So in our next tutorial, what I'm going to be doing is I'm going to be having the user enter two numbers, and we are going to be comparing those numbers, and depending on what numbers they entered, run a certain bit of code. So now, as you can see, we're just building and building to our knowledge of C++ to make better and better programs. So don't skip over if statements, because it's a huge part of C++. So for now, that's all I have for you guys. So thank you guys for watching. In the next tutorial, we're going to be building that calculator thingy, so it's going to be awesome. So thank you guys for watching. Don't forget to subscribe, and don't forget to check out my website. What is going on, guys? It's Bucky, and welcome to your 9th C++ tutorial. And in this tutorial, I'm going to be talking more about functions. Now, I talked about this a little bit in, like, I don't know, a couple tutorials ago, but I want to talk about it again because I really want to stress what functions are and why they are useful in C++ programming. So if you remember, a function is basically a computer program is made up of a bunch of functions. Right now we have one function right here, and basically the job of a function is to do something. So inside function we can give our program a bunch of separate instructions, all followed by a semicolon. So our main function that we already learned is the starting point for every computer program. Every program starts with the function main. So this is one function right here, but let's go ahead and create another function. And in order to do that, go ahead and separate from your main. So before we were coding everything inside the main function, but now we want to create another function. So go outside main right here. Now the first thing that we need is a return type, and this is whenever people build functions, they usually make a calculation and give you back something. For example, if we had a function to calculate the speed of my car, it would give me back a number. If we had a function to calculate my weight, it would give me back a number. Well, sometimes functions make calculations, and sometimes when they don't make calculations, just as like printing something out on the screen, it doesn't really need to calculate anything. So sometimes functions are going to return a number to you. In that case, you would use int. And sometimes they just do stuff like print something out on the screen and don't return any answer to you. Whenever a function doesn't return anything to you, just go ahead and put void. And this means, function, just go ahead and do your thing, and I don't want anything in return. So the very first thing you write is the return type of the function. So this one, you see it returned a number, but this one is just going to print something out on the screen, so it's going to return void. So after this, you go ahead and you name your function. This one is named main, and you can actually name it anything you want. This function is just going to print something out on screen, like I said, so I'm just going to name it print something. Pretty dumb, I know, but hey, it's my function. I can do what I want. So after this, you see that I added two little curly braces, and those are actually called parameters. Whenever your function needs additional information, you add parameters, but we're going to be covering this in the next tutorial. For now, just remember to add them and add nothing in between them. Trust me, I'm going to be covering this in the next tutorial, and I'm going to make it real easy to understand. But after these parentheses, go ahead and add two curly brackets. And just like I said before, this is the body of your function. For example, if you had a function called make peanut butter and jelly, inside your body you would have a set of instructions like get out the bread, next instruction, put peanut butter on one slice, next instruction, put jelly on one slice, lastly, eat it. Well, in the body of our function, we give it each instruction about what we want this function to do. So in our function called print something, the only thing that we want this function to do is print something out on the screen. Easy enough, we already know how to do that. So let's go ahead and cout. Oops, there we go. And what are we going to print out on the screen? Just write like, ooh, I am text on the screen. It's a very feminine function we have here. But anyways, then just go ahead and end the line. Simple enough. So now, whenever we use this function, whenever you use a function, it's called calling the function. Why they did that, I don't know, but just remember whenever I say call the function, I basically just mean use the function. So whenever we call this function, all it's going to do is print out, ooh, I am text on the screen. Simple enough. So let's go ahead and remember, since our computer program starts with main, we need to tell it in main that this is the function that we want to use. So in order to use or call a function, all you do is this. Just go ahead and write print something, empty parameters, and a semicolon. So again, anytime you want to use a function, just go ahead and type the name of the function, empty parameters, and a semicolon. But check this out. Whenever we try and build and run this, we're going to get an error. This is what this little red rectangle means. You can't read my error message because it's down here, but it says printing something was not declared in the scope. And you're saying, alright, what did we do wrong? Because Bucky told me that this function is built perfectly, which it is, but whenever it tried to call it or use it right here, it didn't understand what was going on. So why is our compiler kind of confused? Well, the reason is this. Computer programs work from the top down. It starts at the very top line and it runs downward until it gets to the very end and then it quits. So whenever our computer program was running, it said this, alright, include this file, done. Use this, done. Okay, now start with main. Print something. What the heck? I never seen that before. Is this a function, or are we trying to make a variable, or what the heck are we doing? I don't know what this means. Well, that's because whenever we created our function, we created it after we used it. We need to tell C++ before we use our function that it is actually a function. So we have a couple ways of doing this. Probably the easiest way is just to do this. Go ahead and cut it, and then above your main, go ahead and paste it. And now C++ is going to think like this. Alright, I'm going to include this, simple enough. I'm going to use this, easy enough. And oh, you made a function called print something now. Okay, I'll remember that. So now whenever I call my main and I come across this thing called print something, I know that it's a function that you created. So that's why whenever I build and run it now, it's going to run perfectly without any errors. So that is basically how a computer program works. First, you need to tell it that you are actually creating a function before you can use that function. So if you just try and use it, it's not going to know what it is if you didn't create it first. So we're saying, alright, I'll just remember to create all my functions before I use them. Okay, you can do that, but let me give you an alternative method of doing this. If for some reason you like your main at the top and you like to create your functions after, well, we already know that whenever you try to run this, we're going to get an error. But there is one thing that you can do, and this is called function prototyping. And all this is this. Trust me, it's the easiest thing ever. Go ahead and select your return type, your function name, and the parentheses, and go ahead and copy that. Now, above your main and under your using, go ahead and paste this. This is called the function prototype, and it's pretty much a copy of your function's header. And it basically is saying this. Alright, whenever you run this program now, go ahead and include this, and then we're going to, this is called prototyping a function. This is pretty much telling our C++ program this. Alright, later on, you're going to come across something called print something. Now, whenever you come across it, we don't want you to freak out like you have before, sending us a whole bunch of error messages. What we're telling you right now is we created a function called print something, but you have to go find it. And C++ is going to say, oh, alright, now whenever I try to run my main and I come across this function, instead of giving you an error message, I'm going to know that this is a function that you have somewhere in your program. So I'm not going to freak out. I know this is a function. I know to handle it accordingly. So check it out. Whenever you try and build and run this, it works perfectly. So that is why you need to do one of two things before you use your function in main. One, you can prototype it, or two, you can just go ahead and make your function before main. Either way, whenever you run this function in main, it needs to know beforehand some way that this is a function. So those are your two different ways of doing that. And again, in order to create a function, go ahead and type the return type, the function name, and the parameters. And again, I'm going to be talking about these parameters in the next tutorial. So as long as you understand this and the basis of how to create a function and how to use them in main, you're ready to move on to the next tutorial. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next tutorial. What is going on, guys? It is Bucky, and welcome to your 10th C++ tutorial. And in this tutorial, I'm going to be teaching you guys how to create a function that uses parameters. Now, a parameter is quite simply additional information that that function needs in order to work. So let me give you guys a quick example of this. Say you made a function to calculate the age of someone, how old they were. Well, some additional information you would need before you can calculate that is what year were they born. And once you have this information, you can calculate their age. So let's go ahead, and now that we understand why a function would need additional information, let's go ahead and create a simple a simple function to use additional information. So let's go ahead and create a function that just prints out Bucky's favorite number is blank. We might say Bucky's favorite number is 20. Bucky's favorite number is 68. Bucky's favorite number is 99. Well, since we don't know what my favorite number is yet, we're just going to go ahead and put a variable in place for that number. So since this isn't going to be making any calculations really, we can just go ahead and use void, because that means return nothing. So name your function anything you want. I'm just going to name mine print crap, since that's all it's going to do, print crap out on the screen. And before, we just added these empty parentheses with nothing in between them, and then we coded the body right here. Well, whenever we use a parameter, you actually put that information right in your parentheses. And check this out. You know how I said we didn't know what that number is yet? And that's the additional information that we need. Well, since we don't know what it is yet, we just go ahead and we set it equal to a variable. And since this is an integer, we go ahead and set it equal to the variable int x. You can name your variable anything you want, but I'm going to name mine x because it's really simple, easy to work with. So now we can go ahead and we can add the body of this function. And all we're going to do in this function is print out on the screen Bucky's favorite number is, did I spell everything wrong? Yep, good to go. Bucky's favorite number is X, and then just go ahead and end that line. And now when our function runs, it's going to run something like this. If we say that our favorite number is 20, it's going to say Bucky's favorite number is 20. If we say that our favorite number is 10, Bucky's favorite number is 10. So we can run this function a bunch of times and give it a different piece of information each time, and it's going to work. So let's go ahead and remember, in order to use a function in your main, you just go ahead and you type the function name, and then you add your parentheses and your semicolon at the end. But whenever your function needs an additional piece of information, you need to give it that information inside the parentheses. So we know from making our function that it needs one integer in order to work. So let's go ahead and inside these parentheses give it one integer, 20. So now what it's going to do is, well, let me go ahead and run this and show it to you guys. Bucky's favorite number is 20. Alright, so what happened is this. We said, alright, C++ program, we want to use this print crap method. Well, it said, alright, in order to use this method, I'm going to need one integer. So we gave it the integer 20. So then, whenever in this function it came across the variable x, it just substituted 20 for that. So whenever you're making parameters, you first need to list what type of data and also a variable name. So then whenever we give it that variable, it substitutes that variable for x later on in the program. So for example, let's give it one more example, like 854. Well, now we run it and it says Bucky's favorite number is 854. And that's the beauty of parameters and functions. It doesn't need to be the same every time, so that's why you can use variables. So again, what we did is we created a function and it needed an additional piece of information, which was an integer. And since it didn't know the value yet, it just went ahead and it set it equal to a variable. Then later on in the body, whenever it came across that variable, it knew whatever value you told it to substitute for x, that's what value is substituted for x. So we can run this 100 times with 100 different values if we want. It's going to substitute it for x each time and use that information to plug it in. So that's the basics of how you use functions with parameter. Again, whenever you're creating a parameter, use the data type and a variable name, and whenever you're using the function, don't forget to pass in or give it whatever information it needs. So that's pretty cool, simple enough, we understand that. But in the next tutorial, what I'm going to be teaching you guys is how to use functions that use multiple parameters. What if a function needs more than one piece of information in order to work? Well, I'm going to show you guys how to do that too, and it's a little different than this, so you definitely want to watch that. So once you understand this and understand the basics behind functions and parameters, you're ready to move on to the next tutorial. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. Hey guys, what's up? Welcome to your 11th tutorial, and in this tutorial, I'm just kidding, I'm not going to do this whole tutorial in song. Maybe another tutorial, but I'm not really in the mood this time. So anyways, in this tutorial, what I'm going to be teaching you guys is how to use functions that require multiple parameters. So let me give you guys a quick example of a function that might require multiple parameters. If you were making a calculator and you wanted the user to enter two numbers, well, it doesn't exactly know what those numbers are yet, so we go ahead and we use these numbers as parameters in functions. So as you can see, instead of just a single piece of information, it might need 2 numbers or 8 numbers or 20 numbers. So in order to use multiple parameters in a single function, let me show you guys how to do that. So let's go ahead and make that program right now that just goes and adds 2 numbers together. Well, we can't use void because right now it is making a calculation. It's gonna calculate 2 numbers, find the sum of them, and return to us the answer. So let's go ahead and say, alright, since what you're going to be returning to us is an integer, go ahead and type int. And now what am I going to name my function? Add numbers. Simple, easy, pretty clear. So now we go ahead and make our parameter list and body list. Here's what I do. before I add in my parameters. I don't know why, but you know, I just do it. So what we want to do is we already know that we can use one parameter by going setting the data type and giving it a variable name such as int x. Well, we know that this function is going to need two numbers. We already did one, so how do we say we want to use another number as well? Well, anytime you use more than one parameter, you have to separate it with a comma, and then you give it another piece of information that it's going to need. So it's going to need two numbers. One is going to be called x, and one is going to be called y. So let's go ahead, and now we have a function that takes two extra pieces of information. So we're going to be giving it two integers, x and y. So now let's go ahead and use those numbers somehow. So what we're going to be doing is, let's go ahead and make another variable called answer, and this is just equal to the values of x plus y. So say that the user passed in two numbers, 5 and 6. Well, what we're going to do now is say, alright, 5 equals x, 6 equals y, so answer equals 11. So once we have that answer calculated, all we need to do now is we need to return it. And this pretty much means give it back. So in order to return anything, you just go ahead and write return and then what you want to return. Well, just return the answer. So a return value is basically, once you make your calculation, the final calculation, that's what they get back. So in main, we return 0 because computer programs know whenever you get 0 back, this means that your computer program ran successfully. Well, for this one, we want to return the answer because that means that we calculated the answer, so that's what we're going to return back. So now, when we're using our function, we can just go ahead and print out that value using cout, and then go ahead and write add numbers, and then go ahead and write whatever numbers you want to add. And just like before, whenever we were creating our function, we had to separate these variables with a comma. Whenever we're using this function later on in our main program, we separate the values we're passing it in with a comma as well. So 43 is going to be equal to x, and 86 is going to be equal to y. So let's go ahead and build and run this and check it out. 129. Pretty cool, huh? So what happened is this. We said, alright, we want to print out the return value of this right here. So we can't just go ahead and do this because this is going to go ahead and calculate it, but it's not going to print anything out on the screen. So it actually made that calculation, but nothing's printing out. So in order to print that out, that's why we need that cout to print out the return value of this. So anyways, what we did is we said this. Alright, we want to use this add numbers function right here, but it needs two integers in order to work. It needs an x and a y. So we said, alright, you want two integers? You got it. You got a 43 and an 86. Let's make some magic happen, baby. So it took that 43, plugged it in for x, and 86, plugged it in for y, and it stored that value, or excuse me, it stored the sum of the calculation in a variable called answer. And the answer was like, I don't know what it was, but it took that answer and it returned it back to you. So it says, alright, this is basically equal to 129. So this right here is pretty much just a different way of saying 129, so I'm going to print out 129. And that is how you use functions with multiple parameters. For example, if you wanted to add four numbers together, it would be the same thing. Int x, int y, int a, int b, and then you just go ahead and use those values just like before. So plus a plus b, and then later on when you needed more information, 32, 43. Again, why I'm doing this, I just want to show you guys that you're not only limited to two parameters, you can have as many parameters as you want. You just have to remember to separate them all with a comma. So whether it's 2, 3, or 100, remember to separate them all with a comma in here, and also when you're actually using the function out here. So now you understand the basics of what a function is and how to use multiple parameters, single parameters. You're pretty much a pro with functions now. So once you understand this, you're ready to move on to my next tutorial. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys later. What is going on, guys and gals? Welcome to your 12th C++ tutorial, and in this tutorial I'm going to be giving you guys an introduction to classes and objects. Now, classes are basically an easy way to group all your functions and variables and to group a bunch of stuff together. For example, people like to group similar functions together in the same class. For example, if you had a bunch of functions, maybe working with temperature, or you had a bunch of other related functions, you might want to group them all in the same class. It makes them easier to work with later on. So then, if you have like 1,000 functions, you say, alright, where are all my temperature functions? Because I need them now. Oh, they're in my temperature class. So that is kind of the usefulness of classes and the basics behind that. So let's go ahead and, in order to create a class, we go ahead and make sure you're outside your main. First of all, I want to say that. So I'm going to create mine before my main. And in order to do this, go ahead and type the word class. And now, after this, go ahead and add a space and name your class. Now, people typically name their class with uppercase letters, and I'm going to name mine Bucky's class, just like that. And now go ahead and add curly braces and a semicolon at the end. Now everything, all your functions, all your variables, all your crap goes inside the body of your class right here. So basically, all your crap that you want to go in the class goes in the class body, just like that. And I believe whenever you create a class, it's called declaring a class, but if your teacher ever asks you, make sure you say that. They'll probably be impressed. So before we start adding a bunch of functions and stuff, I want to talk to you guys about something called an access specifier. Now, sometimes you want to make functions that you can only use in your class, and sometimes you want to make functions that anybody can use outside your class. So if you want, for example, the main to be able to use your functions inside your class, you need to make your functions public. If you don't want main to be able to use the functions inside your class, then you would use something called private, but we're going to be going over that later. For now, just remember, whenever you use the public access specifier, it says that you can use it outside of the class. So in order to use that public access specifier, just go ahead and type public with a colon, not a semicolon, just a regular colon. And this means that anything you put after this, you're able to use it outside of this class. So if you didn't have that, then you would only be able to use your stuff right here. And what's the use of that if you need to put it in main? So anyways, make sure you add public. It's called an access specifier if you're taking, a C++ test or something. So now let's go ahead and we create a function just like before. Let me just go ahead and print out something on the screen. So it's not going to make any calculation, so it's just going to print something out, so void. I'm going to name it cool saying, and it's not going to take any parameters, a really simple function here. And all it's going to do is print something out on the screen. Now I got to think of a cool saying. Preaching, wow, totally messed that up. Preaching to the choir. I think that's how you spell choir. Not sure. Hope I don't look like a fool in front of all my subscribers. So now just go ahead and end line. And so all this function is going to do is print out preaching to the choir on the screen. Simple enough. So now you're saying, alright, this class looks good to go. We have the class declaration, class body, we have public, and we even have one function in our class. This is a pretty sweet looking class, so let's go ahead and use this right now. Well, now I want to talk to you guys about the other part of this tutorial. I told you guys I'm going to be talking about classes and objects. I already talked to you guys about classes. Now I want to talk to you guys about objects. An object is how you access the stuff inside of your class. For example, why do you need to make objects at all? Why can't you just write cool sayings just like this and use it just like that? Well, whenever you're making big computer programs and you have a bunch of different classes and a bunch of different functions in them, you may have this cool sayings. You may have a function that says cool sayings inside Bucky class. You may have another function cool sayings inside Tuna class. You may have another function cool sayings inside a class temperature class. Well, how does C++ know what function you want to use? Well, it needs an object, and an object basically tells it what class you're working with. So in order to create an object, it's basically the same as creating a variable. You go ahead and you do this. You type the name of your class, which is Bucky's class, And then after this, you give your object a name. And I'm just going to name mine Bucky's object, just like that. And go ahead and add a semicolon. And now this object, Bucky's object, you use this kind of as the key whenever you want to access the crap inside your class. So now, instead of just writing the function name, we have to write the object name first, like Bucky's object. And then in order to access anything inside the class, we need to use a dot separator. And a dot separator is basically our way of accessing the variables, the functions, all that stuff. So as you can see, we'll put the dot separator up, and it already knows that what we want to do. We want to access CoolSang just like before. Just type the name of the function and empty parameters, and bam, wham, thank you ma'am. We now have a full working program. So let me run this for you real quick to show you guys that it's working, make sure I don't have any errors, and then I'll talk you guys through it one last time. Preaching to the choir. Works perfectly. Pretty cool, huh? So anyways, people make classes in order to group similar functions. So if I had, a program that just had a bunch of cool sayings, I'd have cool sayings 1, cool sayings 2. I would want to put them all in the same class. For now, we only have one function because this is just an example. So we have a function that we put inside the class, and make sure to make it public. That means that main can use it as well. So we have a class, and we made that by making public and threw a function inside it. Pretty cool. So now we wanted to actually use that function that's inside the class. Well, we can't just go ahead and write CoolSang, because if we had a bunch of different classes, it wouldn't know which function named CoolSang to use. So it wouldn't know what class we wanted to use. So in order to use that function, we needed to make an object of that class. So we're saying, alright, we're making an object called Bucky's object, and it is from the Bucky's class. So now whenever we use Bucky's object, it knows that we're going to be working with Bucky's class. So we use Bucky's object CoolSang, and that knows, and that's basically our way of telling C++ that we want to use the CoolSang function, and we want it to come from Bucky's class since we use Bucky's object. So that is why you need objects, classes, and yada yada, all that stuff. So that is your basics of classes and objects, and why you need to make objects before you can use the stuff inside your class. So I know this is kind of confusing, but this is the basics behind object-oriented programming. So if you understand this, then tutorial, then the rest of your programming life is going to be a whole lot more simple. So watch this tutorial, watch it again, until you understand exactly how to make classes and exactly why objects are useful. And once you do, you're ready to move on to the next tutorial. So for now, thank you guys for watching. You guys have no idea how important the information you just learned was. So anyways, thank you guys for watching. Don't forget to subscribe. If you have any questions about any of this, feel free to ask me on thenewboston.com/forum. So yeah, enough of me talking. I'll see you in the next tutorial. What is going on, guys? It's Bucky, and welcome to your 13th C++ tutorial. And in this tutorial, I'm going to be teaching you guys how to use variables and classes. But it's a little different than you guys might expect, so just stick with me, and I'm going to show you guys the wrong way, and then I'm going to show you guys the proper way to use variables in your classes. So before we even get started this tutorial, I want to include the string class as one of our files, because we're going to be working with strings in this tutorial, and if you can't remember, a string is just basically another word for text. So whenever we are outputting things like hey now, brown cow, this text is just another word for a string. So that's what a string is, to give you guys a quick little background on that. So go ahead and include the string class right under your IOStream, right above your namespace. And now, like I said, before I show you guys the proper way to use variables, I want to show you guys the wrong way, because this is a common mistake that a lot of beginners do. So you go ahead and you added your access modifier, public, and say you wanted to make a name variable. Well, name is of course a string, so go ahead and make a variable called name and set it equal to the type string. This is good to go. So now we have a variable in our Bucky class called name. So again, if you remember from last tutorial, in order to use the things in that class, you first need to create an object. So in order to create an object, you type the class name and then the name of your object. I'm going to name mine BO, which does not stand for body odor, stands for Bucky's object. So then we have an object named BO. And with that BO object, we can access variables by using the dot separator and just the name of your variable. So then once we have this variable name from the Bucky's class, we can go ahead and set it equal to any name we want, like Bucky Roberts. And then this variable right here is equal to Bucky Roberts. So then whenever we try to print it out, bo.name, it just goes ahead and it prints out Bucky Roberts on the screen. So you're saying, alright Bucky, that seemed to work pretty darn good to me. So why did you say that that was not the proper way to do stuff? Well, I don't want to get into too much detail, but basically I want to stress this. Making class variables public is generally not good programming practice. I don't want to get into like software engineering, but basically whenever you make your variables public, it makes your programs really easy to mess up. So typically what people like to do is make their variables private. And again, there's some exceptions, but typically you want to make all your variables in your class private. So you're saying, alright, I remember from the last tutorial you told me that whenever I make variables private, I can't access them in main. So whenever you try to run this program right here, we get an error. So you're saying, alright, this is just going to cause me a bunch of headaches. What am I supposed to do? Well, if you remember what I said nothing outside your class can access these variables. So we need to build a public function inside your class to have access to those variables. So that is what we need to do. So let's go ahead and delete all this. And we already made our variable private. So now let's go ahead and make public functions to access them. Because remember, if we make a public function to access that variable, we can use those public functions outside our class in our main. So in order to do that, just go ahead and write public, and now everything you type under here is going to be public. So we want to add two functions. The first one is just going to be, first of all, we're going to want to do two things to this variable name. We want to be able to change it, and that means set it, like set it equal to Bucky, set it equal to Tom, set it equal to Jessica. So we want to be able to set the name. And our second function is just going to get the name. We want to return the value Bucky, we want to return the value Tom, Jessica, whatever. So we have two functions, one to set the variable and one to get the variable. So in order to set the variable, just go ahead and set it equal to void because it's not returning anything, we're just changing the variable. And what people typically do is write set and then your variable name after that. And after this, we're going to go ahead and use the string, and we're going to call X because we're going to be passing in a string such as Bucky Roberts, Jessica Thompson, Tommy, and that variable is going to be equal to the value X. So whenever we set name, we want to change it, all we need to do is set it equal to the variable X, and then it sets it equal to whatever value we passed in. For example, if we say set name Bucky, it's going to treat Bucky as X, and now our name variable is going to be equal Bucky. Simple enough. So that is called our setter method, or excuse me, setter function. A method is actually, if I say method and I actually mean to say function, just remember that I've been teaching like 80 different computer programming languages, and in some languages they call a method a function and vice versa. So I might get it mixed up, but trust me, a method and a function is just the same thing. So anyways, with that little background, I now want to say this. We already built our setter function, how to change that name variable. Well, now we want to build a function to access it. And remember, since we want that name in return, we go ahead and type string because the name is of course a string, a bunch of text. So what people typically do here is instead of set, they write get because they just want to get the name. So go ahead and write get name. It's not going to take any parameters. And in the body, this is probably the easiest thing you're ever going to do. All you do is return the variable. So check it out. We don't have direct access to this variable, so we have to go through functions. In order to change this variable, we go ahead and we use this function. In order just to get the value of the variable, we go ahead and we use this function. So now instead of directly accessing this variable, we can do it through public functions. So again, like I said, the only thing that has access to these private variables are other things inside this class. So if we make those functions public, then we can access that variable, kind of like cheating, you know? So in order to do this, again, in order to use those functions, we again need an object. So Bucky's class, make another BO object, and now under this, if I scroll up, we can go ahead and BO, we can use the functions from that class by using the object name and then the dot separator, and then we'll just go ahead and the first thing we want to do is set a value to that. So go ahead and let me just copy this, paste it right here, and we'll set the name equal to something stupid like Sir Bucky Wallace. If you guys know where the name Sir William Wallace comes from, then leave me a comment below. Congratulations. So now this name variable is equal to the name Sir Bucky Wallace. So instead of accessing it directly, you can see that we went through a function that was public to do so. So now what we can do is we can just, print it out or something stupid. So cout, and in order to print it out, we just can't go ahead and write bo.name because we don't have access to that variable. What we need to do is we need to go through the function getName, just like that. And now what this function does is it returns the name. It's basically a way to make a private a public. Simple as that. So now when we go ahead and print it out, building around this, as long as I don't have any errors, and I don't, check it out. Sir Bucky Wallace. So let me talk you through this one more time. What we did is we wanted to access this private name variable. Well, we couldn't access it directly or else it will give us an error. So what we needed to do is we needed to build public functions. One to change the name and one to get the name. So then later on in our program, whenever we wanted to use those functions, we went ahead and we created an object. And then remember, whenever you want to use anything inside your class, write the object dot separator function object dot separator function, and then we ran our program and it worked pretty darn good. So that is the bad way to use variables and also the proper way to use variables. Again, you can put these variables as public, but it's just bad programming practice and bad software engineering. You're never going to get a job as a computer engineer if you make your variables public. So thank you guys for watching this tutorial. If you have any questions, check out my website, thenewboston.com. It's a pretty sweet website. I definitely want to check it out. So I am going to go get a drink because I've cotton mouth now, and you guys study this tutorial, and I'll see you in the next video. What is up, guys? Welcome to your 14th C++ tutorial, and in this tutorial I'm going to be going over constructors, what they are and why they are useful. So first of all, I want to tell you guys what a constructor is. A constructor is a function that gets called automatically as soon as you create an object. So before, what we could do is we could create an object and use that object to call functions from our class. Well, now as soon as we create this object, it's going to call a function called a constructor. We don't need to explicitly use that object to call a function. It's going to do it automatically. So if you're saying, alright Bucky, you talk the talk, time to walk the walk, show me an example. Well, creating a constructor is incredibly simple. To do so, it's basically the same as creating a function with a couple weird rules. First of all, I need to tell you guys this. Constructors never have a return type, so you don't need to type int or void or string or anything like that. The only thing you need to do is type the constructor name, and the constructor name is always the same as the class name, the exact same. So let's go ahead and copy this and paste it right here, and that's how your C++ program knows that it's a constructor, because once it comes across a function with the same name, it knows that that is the constructor. So let's go ahead and we'll add no parameters, and in the body, what do we want to happen as soon as we create this object? We can have just, maybe it'll print something out on the screen like this will get printed automatically. Pretty cool, huh? So now we have a constructor that's going to get called automatically as soon as you create an object. And you're saying, alright, you keep saying that, but what exactly does that mean? Well, say we have an object from Bucky class named BO. Well, before, we would have to write BO dot yada yada yada, whatever we wanted to use from it. But now, as soon as we create this object, this constructor is going to get called. So let's go ahead, build and run this, and see. This will get printed will blah 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 automatically. So you could see that before we needed to use that object to call functions, but this is a special function called a constructor that gets called automatically as soon as you create that object. So you're saying, alright, that's pretty cool and interesting, but why wouldn't I just, print this out on the screen or something else? What's the use of a constructor? Why would you even want things to happen automatically? Well, typically people don't print things out in their constructors. Actually, if you see anyone printing something out in their constructor, then they're an idiot and you should slap them upside the head, because constructors, the main reason that people make constructors are to give variables an initial value. So, for example, this class has a variable called name, but it might have another variable called age, height, weight, favorite color, favorite sports team. Have all these variables, so as soon as you create an object from that class, you might want to assign a bunch of values to these variables right now. So in order to do that, here is what you do. Whenever you want to take a value and assign it to a variable, you need to add a parameter in your constructor. So let's go ahead and assign a value to this name right here. And in order to do that, we need to pass in string and just name it Z or something. So now what we can do is we're going to be passing it in a string to be setting it equal to name. Well, we already have a function that does that called setName. So in order to do that, just go ahead and call setName with a parameter of Z. So now later on, whenever we want to use our constructor can take a parameter as well. And for our parameter, let's just go ahead and write something like Lucky Bucky Roberts. And now what's going to happen is this. As soon as we create this object, it's going to call a constructor with a parameter Lucky Bucky Roberts. So it's going to go up, see if it has a constructor. Oh, I do. And as my parameter, I need a string. And for a string, we gave it Lucky Bucky Roberts. So anytime it saw Z, it plugged in Lucky Bucky Roberts. So it says, alright, in your constructor, you told me to set the name equal to Lucky Bucky Roberts. So it basically set the name equal to Lucky Bucky Roberts. So pretty much Lucky Bucky Roberts got passed into Z, which got passed into X, which got passed into name. So that's why our name was Lucky Bucky Roberts. So now that our name is Lucky Bucky Roberts, that gets kind of repetitive saying that. But anyways, we can just go ahead and, print it out on the screen or something. So, of course, to access anything in our class, you use the object and, of course, the get name, just like that function. So let's go ahead and build and run this. And we have int main. We got a problem here. Hold on one second. Let me find it. Oh, I see. What the heck? How in the world did I do that? For some reason, I must have actually hit paste or something, but I copied the word name outside my class. I just wrote the word name randomly in the middle of my program. So remember not to put words randomly in the middle of your program or else it won't run. So now let's go ahead and build and run this and check it out. Lucky Bucky Roberts. So that is the basics of a constructor, how they work, and also how you can add a parameter to your constructor. And basically the only times you wouldn't want to add parameters to your constructors is whenever you're taking those variables that are inside your class and you want to set them equal to values initially. So that is basically why a constructor is useful. Whenever you have a bunch of variables in your class and you want to set them equal to values initially, that is how you can do that. So here's that example, and you just printed out our name. So simple enough. So aside from this, I guess I have time to show you this one thing. You might be thinking, alright, so I have an object from this Bucky class named BO, and its name is equal to Lucky Bucky Roberts. So does that mean later on, if I were to create another object from the Bucky class named like BO2, and I set this name equal to, what's even dumber than Lucky Bucky Roberts? Sally McSalad? That's what's on my mind right now. So does that mean that I'm gonna overwrite this one? Well, let's go ahead and print out bo2 dot get name, just like this. So let's go ahead and print it out and see what we get. Lucky Bucky Roberts and Sally McSalad. So what I want to stress is this. Whenever you create an object from a class, each object has its own set of variables. So this object, BO, name is Lucky Bucky Roberts. This object is named Sally McSalad. Even though they're from the same class, it's not like changing the same variables. So even though we set this BO2 equal to Sally McSalad, it didn't overwrite this. They're just from the same template pretty much. So anyways, what I wanted to stress is that you can create multiple objects from the same class and they don't overwrite each other. They're just assigned their each set of variables. Am I saying that right? They're each assigned a set of variables. So yeah, just wanted to stress that before you get into objects and classes more and you get confused. So anyways, that's just a little side note. Stick with constructors, and then once you're good with constructors, you're ready to move on to my next tutorial. But for now, thank you guys for watching, and remember, don't stick words into randomly middle of your program. And yeah, I guess I'll see you in the next video. What is going on, guys? It is Bucky and welcome to your 15th C++ tutorial. And in this tutorial I'm going to teach you guys how to separate your classes and actually add them in different files. So what programmers usually like to do is they like to separate their classes into separate files because it just makes it easier to work with and manage and edit later on. So once we have like a huge program with 100 classes, we don't want all of those classes in the same text file or else it'll just get way too huge. So what they like to do is separate it, and it makes it easier to work on, especially if you're working with a couple people. Maybe one person could work on each file at a time. So anyways, enough of me talking, let me show you guys how to do it. So we have a basic program right here, and we decided that it's time to add a new class. Well, in order to do that, go ahead and press File, New Class, and then we have a new pop-up box that pops up. The first thing we have to do is name our class, and I'm just going to name mine Burrito or something like that. And by default, a couple things are checked, and I don't like to have them checked. There's something called a destructor, and we're not going to deal with any of that yet. So uncheck virtual destructor and also has destructor. And another thing I like to do is I like to keep all my class files in the same directory as my main file. So by default, I think this is unchecked, and what you want to do is check it, and that way all of your files are going to be in the same directory or in the same folder as your main CPP file. So once all your settings look the same as mine, go ahead and press create, and what it's going to do, just go ahead and press yes, yes to that stuff. And what it's going to do is it's going to create a couple files for you. And you're saying, alright Bucky, what the heck is all this? I thought it was just going to give me a blank file. I was going to put my class in it and I was going to be good to go. Well, what we need to do is we create our class a little bit different than we were creating it in the last couple tutorials. We're going to be separating it into two files. So by default, CodeBlocks automatically created pretty much a template of the two files that we need. One is a .h and one is a .cpp. The .h is called the header file and the .cpp is called the C++ source file, and this is where we're going to be writing the code. So first of all, let me explain to you guys what the header file is. The header file is where we're going to be putting all of our classes function prototypes and variable declarations. So remember before I said that whenever you made a function, you could go ahead and prototype it above int main. Well, we're going to be putting all those prototypes in the header. You'll see later on. And aside from that, this .cpp file is where we're going to be actually building the functions themselves. So this is pretty much where all the titles go, and this is where all the bodies go. Basically, it's a little more in-depth than that, but that's a real basic summary. So the first thing that I like to do is get rid of this private and protected because we don't have any of those yet. And another thing that I like to do first off is see this .cpp file where we're saying, alright, how come you needed this using namespace and include in this CPP, but you don't in this CPP? Well, actually you do. So go ahead and copy that and paste it right in there. So again, both of these .cpps should have the same things, include IOStream and using namespace std. So once you have this pasted in your new Burrito CPP, you're going to be good to go. Another thing that you're going to see is this class has already built our constructor for us. Remember in the last tutorial I taught you guys how to build constructors, what they are, pretty much functions that get called automatically. Well, as you can see, this already builds the function prototype and starts building the function body for us. So by default, it just has a comment in it, and I don't even know if I told you guys what comments are, but they're pretty much just little notes that you could write to yourself, have no effect on the program. So let's go ahead and delete this, and before I start writing something in this function, I want to talk to you guys about this last thing that might confuse you guys. It's the colon, colon. What this double colon is it's called the binary scope resolution operator. So just remember that for your test. So that's the technical term. But what the point of it is it's basically saying that this function, which is called burrito because it's a constructor, because it's a constructor, is a member of the class burrito. So usually you're going to have this second one be a different name and this first one stay burrito. But anyways, it's basically saying that this function is a member of this class, and you use that with the two colons right there. If you didn't include those colons, then it wouldn't know what class this burrito was supposed to belong to, so it would give you a bunch of errors. But now, whenever you're making functions, make sure you have the class before it separated by two colons. Again, it's kind of weird seeing it first, but you'll get used to it. So aside from that, let's just go ahead and add something to the constructor. So remember, a constructor gets called automatically as soon as we create the object. So if we go ahead and just go ahead and type like, I am a banana or something like that, something incredibly stupid. So now let's go ahead and write end line. And now whenever we create an object from this class, it's going to print out I am a banana, spelt wrong, but hey, who cares? So before I go ahead and run this program, I want to talk to you guys about one more thing. You're saying, alright, Bucky, I understand how to do this, and it's not like I made C++ or anything, but just out of curiosity, why do you have to separate the .h and .cpp file? Why didn't the users, whoever made C++, just let you make it all in one file? Well, the reason behind that is this. Whenever you're gonna, give these functions to your friends to use, or maybe you're working on it with a team of programmers, or maybe you're just distributing this for sale on the internet. Well, you're going to want to compile this right here and change this all into ones and zeros. And what you're going to be giving the other programmers is this. And the reason you only give them basically the prototypes or the titles of the function is saying, alright, I already built all these functions. They work perfectly. You don't need to change it. All you need to do is to use the functions themselves. So again, whenever you're distributing this, this is going to get compiled and the programmers are going to have access to your functions, but they aren't going to be able to change the function bodies themselves. So anyways, that's a nice little background. You didn't really need to know that for this tutorial, just a nice, little tidbit of information. So that's why you split them up. So the last thing that you need to do is this. In order to use objects from different classes in our main CPP, we need to include the headers. So go ahead and just like your burrito.cpp included the header, we need to include the header right here as well. So now that we included the header, we can use objects from that class. So let's get rid of this cout hello world because we don't need it. So now that we have the constructor doing something, printing out I am banana, we can go ahead and build an object. In order to build an object, we just go ahead and type the class name and some object like BO, and it should be good to go. So let's go ahead and build and run this and see what happens. I am a banana. Simple enough. So to recap one last time, in order to make a new class, you go to File, New Class, you name your class, and make sure you check to have the header, which is this, and the implementation file in the same directory as this. So now what it did is it created all these files for us automatically. The only thing we needed to do is make sure that all of these includes and all of these includes were the same, and basically whenever we wanted to use this class in our main CPP, we needed to include the header. And what this header did is it basically included the whole class, and then we were able to use all the functions, variables, and all the stuff from that class. So I know this is a little weird at first because we're just looking at really small examples and they aren't really useful, don't really tie together to make a full computer program. But later on, once we are building a full computer program, you'll begin to see why classes are useful, why a header is super beneficial, and why you actually do want your function bodies in a separate file. So again, these really small examples might be hard to see, but I just want to break it down easy for you guys so you understand the basics before we dive into something a lot bigger. So for now, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. What is going on, guys? Welcome back to your 16th C++ tutorial, and in this lesson I want to talk to you guys about something called the if statement. Now the if statement is basically a simple way to have your computer program make a very simple decision. So before, when we were programming, we built simple programs and it pretty much just ran line after line after line of code without question. So that's nice and all, but sometimes you want to have your computer program make a simple choice. For example, you might have some code that you only want to run sometimes, and you're saying, alright, why would I even put it in there if I only want to run it sometimes? Well, for example, if you're making a website and you had a message on there that said, "Hello Bucky," well, you would only want to show that message whenever I logged in. You wouldn't want to show it whenever a guy named Tommy logged in or a girl named Jessica logged in. So you would say, if the user is Bucky, then say "Hello Bucky." So you can see that unlike before when we just built a program and you ran it from top to bottom, now we have different routes, different choices that our computer program can make. And the basic decision that each computer can make is made using the if statement. So the syntax for the if statement is incredibly simple. You go ahead and type the keyword if, and in between parentheses right after, you're going to give it a test. Now go ahead and add curly brackets, and if that test is true, then it's going to run the code, whatever you put in here. If it's not true, then it's not going to run the code. So you're going to say, alright, the test is the user Bucky? And the code would be, say "Hello Bucky" on the screen or something like that. So that's a basic example, but of course that isn't real code. So let's go ahead and make a real program that actually works. So what people typically do is they have a variable first of all. So let's go ahead and make int x and set it equal to 10. So now we have a variable equal to 10. They might want to test this to see, is this variable equal to 10? So go ahead and say if x, and now in order to make these simple tests, we use something called comparison operators. And when you're testing numbers, there are 6 different ways you can compare numbers. I know you think, is it equal or not equal? But there's a lot more. First of all, you can test, is x equal to 10? Is x not equal to 10? Is x less than 10, greater than 10, less than or equal to, or greater than or equal to? And let's go ahead and test it besides something other than 10. So we know x is equal to 10. If we want to test if it's the same as 10, we go ahead and write equal 10. And you're saying, alright, first of all, slow down. This doesn't make sense. Why would you not just write if x equals 10? Because that makes sense. Well, the single equal sign is, they already reserved that for setting a value equal to a variable. So if you did this right here, it would think that you were trying to set x equal to 10, and your program's not going to work right. So that's why whenever you're comparing a variable and a value, you need that double equal sign. So this means, alright, test if x is equal to 10, and if it is, let's just go ahead and give it something stupid. Cout OMG I am preggy. That means pregnant in ghetto talk. So let's go ahead and NL, and let's go ahead and run this and see what happens. Build and run, and on the screen it says OMG I am preggy. And why did it do this? Because we had a variable x and it was equal to 10, and then we said, alright, if x is equal to 10, then go ahead and print this out on the screen, and it was, so it printed it out. But if you had something like if x is equal to 87, now we try and build and run it, you see that our computer program didn't print it out because 10 is not equal to 87. So you're saying, alright, I know how to test whether a value is equal to a variable, but what if I want to test if they're not equal? I want to make sure that these values are not equal. Well, the sign for that is explanation point equal sign. This means, alright, if x is not equal to 87, print this out. And it's going to print it out because is 10 equal to 87? No, that doesn't even make sense. So it's going to go ahead and print that out. So that's why we get OMG, I am preggy. So aside from that, let me go over the basics, less than and greater than. If x is less than 87, is 10 less than 87? Yes. And by the way, whenever we have a test and that test is true, we say true. Whenever the test is wrong, we say false. So is 10 less than 87? Yes, 10 is less than 87, so we call this test true. And since it's true, it goes ahead and prints it out. OMG, I am preggy. Now let's go ahead and be like, is 10 greater than 87? No, 10 is not greater than 87, so that's why it didn't print it out right there. So aside from that, there are two other simple ones I want to go over with you guys. There is less than or equal to. So if you had something like, is 10 less than 10, and you just had a basic less sign, then you try to run it and it wouldn't work because 10 is not less than 10, 10 is the same as 10. Well, what if you want to test if a value is less than or equal to another variable? Well, we go ahead and we have our variable 10. Is it less than 10? Nope. Or is it equal to 10? Yes. So this is indeed going to print out OMG, I am preggy. And of course, there is greater than or equal to, but I'm not even going to show you an example because it's pretty self-explanatory what we have. So aside from testing a variable against a value, I just want to tell you guys that you can go ahead and test two variables such as 43. So now we're going to say, alright, is x greater than or equal to y, aka is 10 greater than or equal to 43? Let's go ahead and build and run that, and we see that 10 is not greater and it's not equal to 43. So we can test two variables, and we can even test two numbers, like is 5 greater or equal to 3? And we go ahead and run that, and we print out OMG, I am preggy. But this testing two values is the least common thing. People, I don't want to say always, but I've never seen it where people had two values in here. It's either one variable or two variables. If we go ahead and we just had this code right here, then it would make sense just to forget this whole if statement just like that. Unless you don't know how to compare numbers, then you would have a problem. Then you shouldn't even be watching this tutorial. But for now, I just wanted to talk to you guys about the if statement and how you can use it to make a basic decision. Again, technical terms, whenever your test is positive, we call that a true test. Whenever your test is negative and it doesn't make sense, we call that false. So the code inside the if block is only going to run when your test is true, as you just saw. And again, we have two equal signs for equals. Explanation point equals means not equals. Greater than, less than, greater than, equal to, less than, or equal to. So now you are pro with the if statement. So thank you guys for watching. Don't forget to subscribe, and yeah, see you in the next tutorial. What is going on, guys? Welcome back to your 17th C++ tutorial, and in this tutorial I'm going to be covering something called the if-else statement. Now let's go ahead and first I want to build a basic if statement because an if-else statement is pretty much like an enhanced if statement. So let's go ahead and use the knowledge or the information that we learned in the last tutorial and build on it. So let's go ahead and make a simple program. We have a variable called age, and go ahead and set it equal to whatever your age is. Now go ahead and make a basic if statement. Now if you remember from the last tutorial, all an if statement does is it runs a simple test. If that test is true, it runs a bit of code. If that test is false, it doesn't do anything. So let's go ahead and test age. Say if age is greater than 60, let's go ahead and say cout, wow, you are old. So if the user is over 60, let's go ahead and say you are old. And now let's go ahead and end that line, run this program, and see what we get. We get nothing, and that is because I'm 24, so this program does nothing. But you build this program, you show it to your boss, and you're like, hey, where's my raise? And they're like, wow, this program is impressive and all. However, wouldn't it be nice if we could give a message to the user no matter how old they are? What if instead of skipping this if the test is false, let's give them an alternative message like, if anyone's over 60, we're going to tell them they're old. If anyone is under 60, we're going to tell them, hey, get a job. So you're saying, alright, I suppose I could put another if statement and then write age is less than 60, but you know what? That isn't the best way to do things. I'm going to show you guys something called the if else statement. So the if statement basically ran a simple test. And if that test is true, it ran this bit of code. And if it was false, it did nothing. It skipped it. But now we want to say, alright, else, if the test is false, then we want to run this bit of code. So either way, it's going to run a bit of code either way. If it's true, it's going to run this bit of code. And let me just go ahead and copy that. If it's false, it's going to run this bit of code. But let's not put wow, you're old for either one. If they're under 60, let's go ahead and write you are young, get a job. So now when we go ahead and run our program, unlike before when it says alright, since this test isn't true, I'm just going to skip it. It says alright, this test isn't true, so what am I supposed to do if it's false? Well, I'm supposed to do the else. So let's go ahead and, enough of me talking, run it, and it says you are young, get a job. And of course, if the user is like 87, we run the program and they say, wow, you are old. So now you can see, instead of just having a basic if statement where it was either run a bit of code or do nothing, we now have the option of something happens for true and something happens for false. So now either way, your computer program is going to do something. So that is the basics of an if else statement. So now that you guys know that, let me go even deeper. I said that you can go ahead and run a line of code inside an if statement. Well, you can also run multiple lines of code just by putting them under each other. So if we go ahead and we copy this, we can go ahead and paste it, paste it, paste it. It doesn't matter. You can go ahead and run it 4 times as long as it's in between those braces right there. So we're saying, alright, what if I wanted to do something like this? What if not only I wanted to check if they were over 60, but if they were over 60, I wanted to check if they were over 100. So let's go ahead and do that. So what I want to teach you guys now is that inside if statements, instead of just running simple lines of code, you can also put additional if statements. This is called nesting if statements. So let's go ahead and say if, and remember, this code is only going to run if the user is over 60. So now we want to test if the user is over 100. And then we're going to write cout, why are you still alive? I know this is harsh, but hey, just trying to get the point across. So now let's go ahead and we'll run this bit of code right now. So our program is going to say this. Alright, if the age is over 60, which it is, I'm going to run this bit of code right here. And in this bit of code, I'm going to test if the user is over 100. Well, they're not over 100, but they are over 60, so nothing's going to happen. So we're going to run this, nothing's going to happen. But say our user was 178. Pretty old, huh? Well, we're going to say, alright, is your age over 60? Yes, so now go here. Is your age over 100? Yes, it is. So now run this bit of code right here. And we're going to go ahead and run it, and it's going to say, why are you still alive? Because, come on guys, let's face it. If you're 178 years old, you should be dead. Just saying. So now we begin to see how we can make complex tests and very complex programs. And I know that it's called nesting an if statement inside another if statement, but you can also nest an if else in here, and you can also nest another if in here. And what you can do is you can nest if inside of ifs as many times as you want. But say you wanted to test if the user was over 10, then over 20, then over 30, then over 40, then 50. Well, there's even a more simple way to do this than nesting 1,000 different ifs inside of each other. And I'll probably be teaching you that in the upcoming tutorials. But for now, what I want you guys to take away from this tutorial is, instead of a basic if statement where if the test is false, then it just skips the code, you can now add an else, and what this does is it gives it an alternative choice. And also, aside from that, you can also nest if inside other ifs. So that way you can basically test two things, and if two things are true, run a bit of code. So as long as you understand those concepts, you should be good to go. So for now, thank you guys for watching. Don't forget to subscribe. And yeah, if you have any questions, send me a message on my website, thenewboston.com, and I'll be glad to answer them for you. So thank you for watching. Don't forget to sub, and I will see you in the next tutorial. What is going on, guys? Welcome to your 18th C++ tutorial. And in this tutorial, I'm going to talk to you guys about a while loop. And if you're saying, alright, Bucky, take a step back. I don't even know what a loop is, and now you're trying to talk to me about a special kind of loop? Alright, let me step back. A loop is basically, in computer programming, if you want to take a certain bit of code and run it over and over and over again, you can go ahead and you can just type it on like 100 different lines and it will keep running. Or you can throw it in something called a loop. And what a loop does, it says, alright, write this code only one time, and I'm going to run it as many times as you want me to. So for example, instead of, say we wanted to print hello on the screen 100 times, instead of writing cout hello on 100 different lines, we can only write it on one line and loop it 100 times. So it's a much easier way to make pieces of code run multiple times. So let me show you guys an example. And by the way, now I can talk to you guys about a while loop. There are many different types of loops. A while loop is pretty much the most basic type of loop. In my opinion, it's the easiest. So that's why I'm showing this to you guys first. So let's go ahead and I'll show you guys an example. Go ahead and make a variable called bacon and set it equal to 0. The syntax for a while loop is this. We're going to say while, and then in the parentheses right after it, we're going to give it a test, just like the if statement. We're going to test if bacon is less than or equal to 5, go ahead and run this bit of code over and over again. So let's go ahead and just run cout bacon is, and then it'll say the value of bacon, and then end line. So now, if you were to go ahead and run this, you would say, alright, run it, bacon is 0, bacon is 0, bacon is 0, and you can see that it keeps printing it out over and over. By now, it probably printed it out like 20,000 times. So you're saying, alright, that's kind of useful, I guess, but wouldn't it be more useful if this loop would end? For example, if we only wanted to run it 20 times, how would we go about doing that? Well, sometimes people do want loops that never end, but typically they don't. Typically you want to only have this code run like 5 times or 10 times or 15 times. So how do we control exactly how many times it runs? Well, in order to do that, we usually add a line of code like this. Again, what this test is going to do is test, is bacon less than or equal to 5? And since the value is 0 right now, this test is always going to be true. So in order to make this test false and this loop to stop running, we need to change the value of bacon at some point. So it is equal to 5 or greater than 5. And in order to do that, go ahead and make bacon equals bacon plus 1. Now, each time we run the loop, it's going to go ahead and do its thing right here, and then when it's done, it's going to add 1 to the value of bacon. So the first time it runs, it's going to be 0, and then it's going to add 1 to it, so then it's going to be 1, then it's going to be 2, 3, 4, 5, and by the time it gets to 5, it's going to change it to 6 and not run. So let me go ahead and show you guys. Bacon is 0, 1, 2, 3, 4, 5. So we already know why bacon ran in this case. When bacon was equal to 0, it was less than or equal to 5. 1, yup. 2, yup. 3, 4, 5. Is 5 less than or equal to 5? Yup, so it printed that out. But then, whenever it said, alright, the value of bacon is 5, so I'm going to print out bacon is 5. And then I'm going to add 1 to bacon. So now bacon equals 6. Alright, let's try this loop again. Is 6 less than or equal to 5? No. Finally, the test is false, so I can quit running my dumb loop. So that is how you add, again, like I said, when okay, take a breath, Bucky. You're jumping too fast. Sometimes people want loops to run forever, and when they do, you would do something like the first example I told you. But typically, and I want to say like 95% of the time, people build loops that they only want to run a certain amount of times. For example, 5 times. If you only wanted to run it 5 times, or actually it was 6 in this case, you would add something called this line right here. And this pretty much just changes the value of bacon. So at some point, that test has to be false. If you wanted to run it 20 times, you would go ahead and just change that to 20 and check it out. Bacon is 1, 2, 3, 4, 5, all the way to 20. Pretty cool, huh? So you can change how often your loop runs by a couple things: its starting point, its ending point, or how much you increment that value by. Again, you can add 3 to it each time if you want, and then you would get something like this. 1, add 3 to 4, 7, 10, 13, 16, 19, and when you added 3 to that and it was 22, well, 22 is indeed not less than or equal to 20, so that's when it stopped the loop. So that is the basics of the while loop. Again, all a while loop does is take a certain bit of code and runs it over and over and over again until the test is false. And again, like I said at the very beginning of this tutorial, there are many different loops that allow you to take a bit of code and run it over and over and over again. A while loop is pretty much just the most basic kind. So make sure whenever building your while loops not to forget to change that value, or your loop's going to run forever, and who wants that? So for now, thank you guys for watching. I'm actually going to go make some bacon right now, so you guys sit tight, rewatch this tutorial, and once you understand the syntax of how a while loop works, you're ready to move on to my next video. So again, thank you, don't forget to subscribe, and I'll see you in the next video. What is going on, guys? It's Bucky, and welcome to your 19th C++ tutorial. And you know what? All these nice little quick examples are fine and dandy, but let's go ahead and build a program that is actually somewhat useful, a program that you can use. And maybe your teacher assigned you something, or maybe your boss came to you and was like, you know what, Bucky, I want you to make a program that allows the user to enter 5 different numbers, and then I want you to total the numbers for them. But you have to use a while loop. So we're saying, alright, no problem. So here is how I would go about making this program. And by the way, this is some nice little programming tips. You start with the basics of your program and you do it in little baby steps. So first of all, I want to make a loop that runs 5 different times. So what I would do is make a loop int x, set this variable equal to 1. This is just going to be the looping variable. While x is less than or equal to 5, let's just go ahead and print out something to make sure our loop is working. Cout x end line. So that's going to print out x, and you know how I said that in order to add 1 to x each time, you go ahead and write x equals x plus 1. Well, you can do that, but let me let you guys in on a little secret. If you go ahead and write x plus plus, this is the exact same as writing x equals x plus 1. It's just a quicker and easier way to do things, and that's actually where the name C++ came from. They wanted it to be cute, and anyways, that's the history of C++. It came from an old language called C, and they added 2 little plus signs to it, thought it was cute. So anyways, that's your history of C, but what we're worried about is making sure that we have a working loop that runs 5 times. So let's go ahead and run this. So alright, 1, 2, 3, 4, 5. Our loop is working perfectly. We can now move on to the next step. And by the way, this was just a tester line. We don't really need that in our program. So we're saying, alright, our boss told us to make a program so the user can enter 5 different numbers. So we already know that the CIN is the way that the user can enter a number, but we probably need to store that number in a variable. So let's go ahead and store that number in a variable number. And since we don't know the value yet, we can't set that equal to anything yet. So what we would do in order to have the user enter a number 5 times is inside this loop, go ahead and write CIN number. Now our loop is going to run 5 times, and the user is going to enter a number each time before the program quits. So what I would do now is test the program again just to make sure it's working. Alright, 43, 54, 66, 2, and 3. Enter. Our program's done. So now we see not only do we got a loop that runs 5 times, but we also have the user enter 5 different numbers. So our program is working fine and dandy so far. So we're saying, alright, now what's the last thing he said? Oh yeah, he wanted to find a sum of all those numbers and print it out to the user or something. So we're saying, alright, now not only a number variable, but we need another variable to hold the sum or the total of all those numbers. So what I would do is go ahead and put int total, and by default their total is going to be 0 because they didn't enter any numbers yet. That's what we know. So now what we can do is this. You might be thinking this. So just go ahead and set total equal to number. But whenever we run this, it's not going to work because say they enter 10 the first time, where then total is equal to 10. Okay, it's working fine so far. But the next time they enter 8 and we were expecting 18. Well, this isn't being added to total. Total is now being changed to 8. So instead of being 18, it's just 8. So this isn't going to work. So what we need to do is do this. Total equals the old total plus the new number. So now what happens is this. Whenever they enter 10, it's going to be 0 plus 10. Total is equal to 10. The next time they enter 8, 8 equals number. So 10 plus 8 equals the new total of 18. So let's go ahead and once this loop is done running, let's go ahead and just give them a nice little printout on the screen. Your total is total, and might as well end that line. Why not? So let's go ahead and run this program, and now let's go ahead and run it and make sure it works. So let's go ahead and put 10, enter, 8, enter, 2, enter, 5, enter, 5, enter. Your total is 30. So alright, let's go review this one last time. It seems like everything is working fine. Let's just go ahead and make sure. Well, I guess I can cover that up. That says end line there. Now I'm covering it up. So basically, the first thing we did is we got a loop that worked. Then we wanted to have the user enter a number, and then we did something with that number. So what happened is this. The first time the user entered a number, it was 10. So the total, which was 0 before, is now equal to 0 plus 10. So now total equals 10. The next number they entered was 8. So now the new total is 10 plus 8, which was 18. The next number they entered was 2. So 18 plus 2, now total equals 20. Next number was 5, now it equals 25. The last one was 5 also, now it equals 30. So this is basically saying, alright, take the new value of total and set it equal to the old value plus the number that they entered. And at the end, we just said your total is 30. Works pretty good. So let's go ahead and just to make sure that it's working good, let's really test this. Add some big numbers like this. Why do I keep entering the same number each time? And that. So, okay, I'm not going to check this in my head, but you guys can go ahead and check that on a calculator. And if it works, then it means we just built the best calculator on earth. So I'm actually going to go ahead and copy this and email this to Microsoft, and hopefully they pay me, just a couple $1,000,000 for it. So you go ahead, and what I want to stress in this tutorial is this. Not only this is how you build a basic program to, it's just an example of why a while loop would be useful, but also whenever you're building programs, take it in baby steps. Do the most basic thing first, and then once you got that working, go on to the next step. And then once that working, you can go on to the final step. And now we can do something like maybe we can find the average of all these numbers, or maybe we can find the product or the quotient or something stupid. So again, take your program in baby steps. That way you don't try to build a whole program and then at the end when you got 10 different errors, you're saying, alright, what went wrong? So that is the basics of not only how to be a good programmer, but also how to use the while loop in a meaningful way. So for now, thank you guys for watching. Like I said, just going to go ahead, cut this, and paste it to Microsoft. And yeah, I'll see you in the next tutorial when I'm a millionaire. What's going on, guys? Welcome to your 20th tutorial. And in this tutorial, I'm going to be teaching you guys how to build a Sentinel controlled program. Now, let me explain to you guys what that is. You remember in the last tutorial where we built that program and we ran a loop 5 times, and each time we allowed the user to enter a number? Well, sometimes we're going to want to build programs where we don't know how many times the user wants to enter a number. So if you we're calculating the average grades for kids in your class, you know how many kids are in your class. If you were calculating the average age of people in your family, you know how many people in your family. But if we built a program and we just sold it to everyone in the world, everyone's family has a different size. Every teacher's class size is different, so we don't know exactly how long to make that loop last. So what we do instead is we give a special code, and this code is usually something like -1. And we use this because ages and weights and number of things cannot be -1. So whenever we enter -1, this is when our program knows to stop and make its calculations or do whatever it does. So let's go ahead, and I'm going to be building a program that we enter the ages of a bunch of people. How many, we don't know yet, but we're going to enter the ages of a bunch of people. What our program is going to do is figure out how many people we entered and calculate the average age of all those people. So let's go ahead, and it's pretty much an age averager. If I was to make this program, I would name it Age Averager 5.0. Why 5.0? I don't know, I just like 5. So let's go ahead, and we're going to need some variables. The first variable we need is someplace for the user to enter and store that age, each age at a time. So they're going to enter someone's age like 32. We're going to store it in the variable age. After this, we need some way to keep track of all those ages a total. So if they enter 32, then 32. We want this to store the total, which would be 64, because we're going to be averaging it later on. So int, just name it like age total. And this, of course, is equal to 0 first, but it's going to be the total of everyone's age combined. And the third thing we need to keep track of is how many people did they enter. So you take the total over how many people they entered, and this gives us the average age. So int number of people entered. And I don't really like making variables that long because it's easy to make a typo the longer your variable is, but it's descriptive for this tutorial. So the first thing we want to do is just write a prompt on the screen. Cout enter first person's age or -1 to quit. So what we're going to be doing is our code is -1. Whenever we get the input -1 from the user, we know that they want to quit the program. So let's go ahead and then give them something to enter, age. So they're going to enter a number, and it's going to be stored in the variable age. So now we just need to test to make sure it's not equal to -1. And we need to loop this program as many times as possible as long as the value is not equal to -1. So as long as age is not equal to -1, go ahead and run this program. And at the heart of this program is this. What we're going to be doing is we're going to be taking that age total, and it's going to be a running total of the old age total plus the new value that they entered for age. So the first time, say they enter 6, it's going to be 0 plus 6. The next time they enter 10, it's going to be 6 plus 10, so the total would be 16. So then when we divide it by the number of people, which would be 2, their average age is 8. So let's go ahead, and now each time this loop runs, it means that they entered a new person. So let's go ahead and just write number of people entered plus plus, because remember, plus plus is the same as adding 1 to it each time. So now we said, alright, our age total is good and the number of people entered is good. So now every time we run this loop, we want to give them another opportunity to hit -1 or enter someone's age. So make another cout and just write something like enter next person's age or -1 to quit. So right now they're going to enter -1 or someone's age. And let's just go ahead and end that line. So now, semicolon, there we go. So now we're going to store that value in age. So they're going to keep running this, and every time it runs, they're going to have a chance to input an age. What this loop is going to do is check, and it's going to run the loop over and over and over and over again until the user enters -1. once they enter -1, it's going to say, alright, that's my sign to bail out of this loop and go ahead and make my calculations. So for calculations, let's first go ahead and make sure our program is going to work properly by saying, let's first tell them number of people entered. And I know I spelled that wrong. Big deal. Who cares? And now we just output number of people entered. Looks good. End line. And after this, what we want to do is we want to find the average age of all those people. So cout average age, and then we just go ahead, and the formula for average age is age total over number of people entered. For example, if your age total is 100 and you entered 10 people, then the average age would be 10. So let's go ahead and run this program first to see if it works, see if I forgot any semicolons or anything. Alright, so the program is up and running. It looks good. So what I like to do whenever I build programs like this is I like to enter values that I already can calculate in my head just to make sure that the computer is calculating. So let's go ahead and enter a person with the age of 10, the person with the age of 20, and a person with the age of 30. Now I know that whenever I average these together, 10, 20, and 30, well, that's 60. So 60 divided by 3 is 20. So I'm going to be expecting 20. And that way I know that my program's working correctly. So let's go ahead and quit by hitting -1 and go ahead and hit enter. And it says number of people entered 3, which is correct, 10, 20, and 30. Average age of them is 20 because 60 divided by 3 is 20. So that is pretty cool, and our program works fine. Number of people entered, it got that right, and it calculated their average age right. So that's what I like to do before I enter big numbers like 87, 68, 5, and all those. Like 5's a real big number. So anyways, how our program worked is this. What we did is we built 3 variables. Well, let me just go ahead and skip to the good stuff. It says, alright, enter the first person's age. And we went ahead and we entered 10 right here. So it says, alright, is 10 equal to -1? Nope. So let's go ahead and run this right here. I'm going to go ahead and store 10 in age total and change the number of people entered to 1. And now go ahead and give me another age. Well, we went ahead and we entered 20. So now 20 plus 10, our age total was now 30. And our number of people entered was 2. So it said, alright, give it to me again. We entered 30. So now our age total was 30 plus 30, which is 60, and number of people entered was 3. So then it said, alright, now give me another age, or -1 to quit. We gave it -1 to quit, so it bailed out of this loop, and it went ahead and just make the calculations. For this calculation, it just printed out the number of people entered, which was 3. And for this one, it said the age total, which was 60, divided by the number of people entered, which was of course 3. 60 over 3 is of course 20. So again, that is called a Sentinel control loop because we can run this program in, it doesn't matter how many numbers we enter. You know, we're not limited to 5 or 10 or anything. As soon as we hit -1, it calculates how many people we entered and their average age. So again, this is a much more dynamic program in the sense that you're not only limited to a certain number, but you can disperse this, you know, maybe a bunch of different types of people, and it doesn't matter their sample size. Any amount of people in this program is still going to continue to work fine. So that is the beauty of a Sentinel controlled program. These are the loops that you're going to be using more often rather than, you know, a fixed number. So get used to it, become familiar with it, and once you are, you're good to go. So for now, that's all I have for you guys. In the next tutorial, don't know what I'm going to be covering, but my throat is dry now, so I need to go get a drink of water, and you need to watch more of my videos or something. I don't know. So thank you guys for watching. Don't forget to subscribe, and I'll see you next time. What's going on, guys? Welcome to your 21st C++ tutorial. And before I even get started with this tutorial, I just want to mention one thing that you guys probably noticed already, and that is I don't have return 0 at the end of my main. And that is because I just found out that, well, let me say this. In the old C++ ways, you had to have that return 0 statement, but now the new version or whatever, whenever you don't include return 0 at the end of your main, C++ just assumes you return 0 after the last statement. So, if you go ahead and type your program, you can either put it if you're a, old school programmer, or you can not include it and it will just assume you have return 0. But for the rest of these tutorials, I'm going to exclude it, so, don't freak out that it isn't there. So anyways, let's go ahead and get to the heart of this tutorial, and that's assignment operators and increment operators. Now we already know, well, let's go ahead and get a variable first. Set x equal to 10. Looks good. So we already know we can do something like this. X plus equals 10, and this is basically the same as writing x equals x plus 10. So then whenever let me just go ahead and end this line and print it out, we go ahead and we get 20, just like that. So what it does is it takes this value, adds it to x, and sets it equal to the new x variable. So I already told you guys plus equals is a shortcut, but I also want to go over all of them so when you see them in programming you don't get confused. X, well, let's change this to 5. It's weird if they're the same number. So x minus equal 5 equals 10 minus 5, and assigns that to the new value of x. So let's go ahead and see that that is 5. Now if we go ahead and see multiplies equals, what this would do is do 10 times 5 and set it equal to 50. And the last one, without getting in the weird stuff, is divide equals 5. And this, of course, is 2. So what this does is it basically takes the old value of x, divides it by this value, and sets it equal to the new value of x. So aside from that, there's one more, and I rarely use it this way. I hate writing it like this, and I hate seeing other people write it like this because it's confusing. This is going to be a bad example because 10 divided by 5 is 2 with no remainder, so it'll be 0. But if we go ahead and throw like 3, something like this, what this does is it takes the old value of x, divides it by 3, and it stores the remainder in 1. So now x is going to be equal to 1. Right like that. So those are all your assignment operators: plus, minus, multiply, divide, and modulus, which is a remainder. So now whenever you come across them in programming, you'll understand what they mean. So now what I want to talk to you guys about is those increment operators. So let's go ahead and get a new value, 20. That's a little bit better. It's my favorite number. So you know how I told you guys that you could do something like this, x plus plus, and this was the same thing as adding 1 to x. Simple enough, right? Not exactly, because there are two different versions of this increment operator, and I'm going to show you the differences between both. So let's go ahead and see out x n line. Let's go ahead and run this and take a look at what happens. So our initial value of x was equal to 20, and then we ran this line of code and it printed 20, alright, and then we ran this line and it was equal to 21. Well, what the increment operator is doing, whenever you write variable with plus plus after it, it's going to go ahead and run this line of code, and then it's going to add 1 to that variable. So it runs this line of code, x is still 20, then when it gets done running, it assigns 21 to x, and then it runs this one. So that's why it was 20, 21. So if you're saying, alright, simple enough, what's the other version? The other version is this. Whenever the increment operator is before the variable, like plus plus x instead of x plus plus, what happens is you can see whenever we run the program, it goes 21, 21. So what this does before the variable is it adds 1 first, and then it runs the statement. So it adds 1 right here and then runs it. So right here, the value of x is getting set to 21, and then run it 21, still 21, 21. So it's basically, if your pluses are before the x, it's going to add 1 before it runs it. If your pluses are after the x, it's going to run the line of code and then add 1 to the variable. So if you're building a program and you're off by 1, maybe you're running a loop or something and you're always off by 1, chances are your pluses are on the wrong side, either this side or that side. So this is a common error, and it's actually something that people have a hard concept understanding. But just remember, where you add your pluses indicate when it's going to add 1, before or after the statement. And if you remember it like that, it'll be simple enough. So now you understand that you don't need to return 0. You understand all the assignment operators. That's actually kind of a tongue twister. Assignment operators, assignment operators, assignment operators. Got it. And now you understand increment operators, which is plus plus x and x plus plus. Oh, and one other thing, there's also minus minus x, and what this does, of course, is subtracts it, and x minus minus, but I don't need to show you guys that. So just remember those four different increment operators, all those assignment operators, and you don't need to return 0 anymore, and you'll be good to go. So thank you guys for watching my 21st tutorial. No idea what I'm going to cover in the next tutorial, but it's going to be sweet. So thank you guys again, and I will see you guys later. What's going on, guys? It is Bucky, and welcome to your 22nd C++ tutorial. And in this tutorial, I'm going to be talking to you guys about a different kind of loop than the while loop. This is called the for loop. Now, if you guys remember, a while loop was basically something that took a bit of code and ran it over and over and over again. This isn't only for while loop, but all loops do the exact same thing. They take a bit of code and they run it over and over and over again. The only difference is different loops, you have to set them up in different kinds of ways. So anyways, I already told you guys how to build a while loop. Simple enough. So now let's go ahead and take a look at the syntax for a for loop. And the first thing you need is the word for. Now after this you add parentheses. Now inside your parentheses, your for loop requires three pieces of information: a starting value, an ending value, and how much do you want to increment it by. For example, if we started at 10 and we ended at 20 and we wanted to increment it by 2, it would be 10, 12, 14, 16, 18, 20. So let's go ahead and build a simple loop that starts at 1, ends at 10, and it increments by 1. Pretty much 1 to 10, counting by ones. So the first thing we need is to initialize a variable. So int x equals 1. Now every piece of information you separate it with a semicolon. Now after this, it's pretty much the same as the test in the while loop. How long do you want to let your loop run? Well, let our loop run as long as x is less than 10. So it's going to go from 1 to 9, because remember, when it gets to 10, 10 is not less than 10. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. But how does it know to go 1 at a time instead of 2 at a time or 5 at a time? Well, that's that last piece of information that this loop needs. X plus plus, and if you remember from the last tutorial, this means add 1 to x every time. You can also do x plus equals 1, but x plus plus is a lot easier. It saves you one character and, only two different characters. But anyways, I'm rambling. Enough of me talking. So basically, the syntax for a for loop is this: initialize a variable with a starting value, give it an ending value, and say how much you want to increment it by each time. So now we would just do something like this: cout, print out x on the screen, and print it out on a new line every time. So let's go ahead and build and run this and see what we get. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we started at 1, and we ran the loop the whole time as long as x was less than 10. So that's why 10 isn't printed out, because 10 is not less than 10, but all these values are. And since we wrote x plus plus, it went by 1 each time. 1, 2, 3, 4, 5. Kept adding 1 until we got to 9. So now, let me go ahead and show you different, we'll just add some different values so you guys can clearly see. Instead of 1, let's start at 5. By the way, 0 and 1 are going to be your most basic starting points. But, you can use anything you want, but people typically stick with 0 or 1. Let's go all the way to 50, and let's go ahead and increment it by 5 by writing x plus equals 5, which means add 5 to x each time and assign that to the new value. So now if you go ahead and build and run this, we go ahead and we have 5 all the way to 45 by 5s, and we start at 5 right here. Well, all the way till we were less than 50, and that's why it doesn't print out 50, because 50 is not less than 50, it's equal to 50, but 45 and all these values are less than 50, and we told it to add 5 to x each time. Simple enough. So basically, starting point, ending point, how much you want it to change each time. So now, those are, the basic Bucky terms, but if you're taking a test, I want to give you guys the technical terms. This is called initialization, where you start off a variable. This is called the loop continuation condition, basically when you're on the end. And this is called the increment. So with those three things, it has all the information that your loop needs: where to start, where to end, how much to go by. So this is a really basic example of the for loop. All we did is print out numbers and we didn't really do anything useful except learn the for loop. So in the next tutorial, I'm going to be showing you guys an example of why the for loop, it's basically this. I'm going to show you guys the for loop in a cool program, and I'm going to show you guys how it's going to be used to do stuff like calculate how much money you can make in the stock market. So if you don't know what I'm talking about yet, just check out my next tutorial because it's going to be awesome and we're going to be building a super cool program. So thank you guys for watching. Don't forget to subscribe and I'll see you guys next video. What is going on, guys? It's Bucky and welcome to your 23rd tutorial. And in this tutorial I'm going to be building a simple program and I'm going to be using the for loop, and I'm just going to be using it to show you guys that it is actually useful outside of just showing you guys examples. So what we're going to be doing is we're going to start with $10,000 and we're going to invest in the stock market, and we're smart enough to earn 1% each day on our money. So at the end of 20 or 30 days, how much money did we make? So, it's a little funner program than what we've been programming before. It's a little cooler, a little break from just basic examples. So before I get started, I want to mention this. In our formula for calculating interest rate, we need to use a function called power, and that's included in the CMath library. So make sure you include this before you get started in this tutorial. So let's go ahead and get down to it. Now we're going to be calculating interest rates and stuff like that. So we're going to be needing to work with decimal points like 0.01, 0.02 for 2%. But we already know int. So can we use integers when working with decimal points like this? No, we can't. Int is for whole numbers only, like 98, 4, 54. Int is for whole numbers without a decimal place. So in order to use a decimal place, we need to have a new type of variable, and that's called float. Float is basically the data type that allows you to work with decimal places. There are a couple different ones, but this is one of them, one of the most popular ones. So let's go ahead and make a variable called a, and this is going to be the amount we're trying to figure out. How much money did we make? The next variable we need is called principal. So float p equals your principal amount. In everyday terms, how much money did you invest? How much money did you start with? Well, say we just had $10,000 laying around, so let's go ahead and start with that. I wish I had $10,000 around, but hey, we can dream, can't we? So now, let's go ahead and say this. Our last variable is rate, so I'm going to set it equal to r, and that's how much interest do you want to earn each day. And let's say we can earn 1% each day, and that's 0.01. If you had 2%, it would be 0.02. Make sure not to put 2 or 1 for this. You need 0.01, or else it's not going to work. So let's go ahead and use the for loop to run through each day. So what this is going to be doing is looping through each day one by one. 1, 2, 3, 4, 5, 6, 7 days, and each day is going to give us a dollar amount. How much money did we earn that day at 1%? So of course the for loop is going to loop through days. Let's go ahead and make a variable called day, int day, and we'll start at day 1, obviously, and the next parameter it needs is how long do you want to invest your money for. So let's say 20 days. So day is less than or equal to 20 days. And of course day plus plus, because one day at a time. We're not skipping any days and we're not taking any vacation time here. So now the formula for interest rate is this. The amount of money that you earned is equal to the principal amount times, and in parentheses put this, actually no, not yet, the principal amount times the power, and this is where you put parentheses, 1 plus the rate, and this would be, let me go ahead and type this out. I can't talk and tell you guys financial formulas at the same time. The formula for calculating interest rate is this. The amount of money you're going to make is equal to your principal investment times 1 plus rate, and the rate would be 0.01 in this case, to the day exponent. So it would be like 1%, 1.01% to the 20th power. So I mean, it's a weird formula, but that's how you calculate it. Just trust me, it works. So anyways, now what we have to do is just print out on the screen how much money we're going to make. So let's give it a nice little print thing. Let's go ahead and print the day first. And then just want to give it a nice little spacer here. There we go. and then we go ahead and write A. A is the amount of money that we're making, and then go ahead and we'll print this on a new line each time. So let's go ahead and run it, and you'll see what I'm talking about whenever I run it. So here is the day to the left, 1 through 20. We start off, and at the end of the first day, if we invest $10,000 at 1%, we earn $100 at the end of that first day. At the end of the ninth day, we almost earned $11,000. If we invested $10,000 and we earned 1% each day for 20 days, at the end of your 20th day, you would earn over $12,000. Well, you would actually earn $2,000, but calculating the money you already had in there, you would have over $12,000. That's pretty sweet, huh? So now you know why everyone wants to get in stock trading, because basically by just sitting at your computer and clicking buttons, making trades, you can earn $2,000 in 20 days. Pretty sweet, huh? So since you know this is fake money and we're just dreaming, let's say that we were a genius like Warren Buffett or Bill Gates, and we were smart enough to earn 3% each day. And let's say we invested this for 30 days. So go ahead and let me run this. Oh mama, check this out. If you invest in money for 30 days and you earn just 3% on your money each day, at the end of 30 days or 1 month, you would over double your money. You would have $24,000 and more, and enough to go out to Taco Bell. So that is pretty sweet, and this makes me second guess my career as a computer programmer and kind of makes me want to get in the stock market. But by the way, before you guys get into the stock market, earning 3% a year would be good nowadays. Earning 3% a day is virtually impossible unless you're like Warren Buffett. So anyways, there is your tutorial on a useful way to use the for loop in program, and also, you know, some financial advice too, the formula for APR. So there you go, and I hope you guys learned at least something from this tutorial, and hopefully I didn't get you addicted to the stock market, because hey, we got more C++ to learn, guys. So thank you guys for watching. Don't forget to subscribe, and yeah, I'll see you guys later. What is going on, guys? It's Bucky, and welcome to your 24th tutorial in C++. And in this tutorial, we're going to be covering the do while loop. But you guys probably already knew that, because I got a feeling that the title is right above this video. And you know what else I do a lot? I tell you guys, this is probably going to be a short video, and I just realized that the time is right under the video. So I don't know why I say those things, but it's habit. I'm going to continue to say those things, so get over it. So anyways, we're going to be covering the do while loop in this tutorial. And if you remember from, I don't know, however many tutorials those go, I talked to you guys about the while loop. And the while loop was basically a loop that you had a test, and if that test was true, then you ran a bit of code inside. While the do while loop is basically the while loop flipped upside down. What the do while loop does is it runs the bit of code first, and then it runs the test. So let's go ahead and let me show it to you guys, and you guys will understand better what it means. Let's go ahead and get a counting variable called x and set it equal to 1. This is our starting point. Now the syntax for a do while loop is do, and then you go ahead and add some code in the body. So let's just go ahead and print out x. And then after this, we need to increment x, or else the loop's going to run forever. So x plus plus. And now after the body, immediately after it, you write while. And then after this, you have your test ended with a semicolon. A lot of people forget that semicolon, because in basic while loop, there is no semicolon if it's not in the body. So don't forget to put this semicolon right here. So let's give it a simple test like x is less than 10. Now go ahead and run this and check it out. Just like the while loop, it ran the same bit of code, printed out x on the screen, from 1 all the way to 9. Pretty cool, huh? So we're saying, alright, a couple of things are kind of weird here. First of all, why is this loop even useful? Because it seems like a bad while loop, because isn't the point of a loop to run the test first? And if the test is true, then run the bit of code. But if it's false, then don't run the bit of code. Well, people use do loop mainly for this reason. Whenever you have code in here and you need it to run at least one time, it's guaranteed to run at least that one time. And the reason is this. Say you have a test that is false, like 99. Well, this test is going to come false as soon as it hits it. 99 is not less than 10. 99 is a whole lot bigger than 10. So whenever you run this, it's just going to print out 99. So as you can see, it ensures that you run your code at least one time before testing it at all. So no matter what this value is, it's going to do it one time and then test it. So whenever you want to run your code, guarantee that it runs at least one time. This is what you do. So that's the main reason that people use a do while loop, to ensure their code runs at least one time. Again, if you have a basic program and you just want to loop it normally, your best bet is to run the while loop or the for loop, because those are your basic loops where you test it, and then depending on the test, you run your program. So again, this is basically a weird kind of loop. This is probably the most uncommon loop, but whenever you come across it, I wanted you guys to pick up on it, understand what it's doing, and why some people prefer it over the while loop. So now that you have knowledge of the do while loop, and you guys know that it's really not that common in programming, so you don't want to use it that often, you at least know what it does and how it, I was going to say how it worked. Well, yeah, that makes sense, and how it works. So anyways, that's all I have to cover for the do while loop. Pretty simple, basically a while loop flipped upside down. So thank you guys for watching. Don't forget to subscribe, and yep, I'll see you in the next video. What is going on, guys? Welcome to your 25th C++ tutorial, and in this tutorial, I'm going to be talking to you guys about a really cool feature of C++, not only C++, this is basically in all computer programming languages, but it's called the switch statement. And the switch statement in your computer programming career is going to save you a whole lot of time and headaches. So let me give you guys an example of when you would use this. Say you have a variable like age and you want to test the age of a user, and you had a bunch of different like statements you wanted to print out depending on how old they were. So if they were 16, you would say congratulations, here's a new car since you can drive now. If they were 18, you would say go buy a lottery ticket. If they were 21, you would say go buy some beer. So you have all these different values that you could apply to the same variable. So with our knowledge so far, we can build a program like this doing this. If age equals 16, let's go ahead and type our body, and then after this, if age equals this, yada yada, if age equals that, and that, and that. Well, all those if statements are getting pretty old, so wouldn't it be cool if we could combine this all in kind of a compact statement? Well, it would be cool, but unfortunately we can't. So on with the next tutorial. In the next tutorial, I'm just kidding, we actually can do this, and that is through the use of something called a switch statement. Now in order to use a switch statement, here is what you do. Type the word switch. Now in parentheses right after that, write the variable that you want to test. Well, we want to test the value of age, so go ahead and type age right in there. Now after this, go ahead and add the body to your switch statement. Now inside your body, you're going to give it all the values which you think age is equal to. And we're going to be giving it in the form of cases. So pretty much we're saying this. In case they enter 16, but don't write in case, it's only case. So in the case of 16, and then write a colon. Now after this colon, you write whatever statements you want your computer programming to perform, or computer program to perform. You're the computer programmer, this is computer programming. There, I got it straight in my brain. So in case the value of age equals 16, let's just go ahead and print something stupid out on the screen like cout, hey, you can drive now. And go ahead and end line, why not? And after this, add a keyword that says break. Now, I'm going to be talking about break later on because it's easier if I make the whole program first before I talk about it. Now after this, we can write something like, alright, what if the case is 18? Then what are we going to print out then? Cout on the screen, go buy some lotto tickets, because you can do that at 18. Now end line, and of course after this, add that break statement that we don't know what it does yet, but we will. And let's go ahead and give it one more case, why not? In the case of 21, the best one, let's go ahead and cout, buy me some beer. And go ahead and end that line. So now you can see, through the use of this switch statement, it basically saved us the trouble and the time of making a bunch of different if statements. So instead of 3 different if statements three different if statements, we only had one switch, and we just tested a bunch of different cases. So the last thing is default. And what default means is if none of these cases were true, if they entered a value like 2 or something like that, it ran through all these cases. Was it equal to 16? Nope. 18? Nope. 21? Nope. So what do you want me to perform by default? And of course, you don't need like default 2 because it doesn't have a value. It just, if all of these values failed, then what do you want me to do by default? By default, we'll just write cout, sorry, you get nothing, because 16, 18, and 21, that's where the important stuff happens. Everything else is just a birthday. So let's go ahead and end that line. And one thing you might notice, whenever you build and run this, you're saying, alright, sorry you get nothing because you're 2, but before you go ahead and build and run this, why didn't I add a break at the end of default, and what exactly is break? Well, this break keyword right here pretty much means end the switch. So you're saying, alright, why would I want to end it? Why doesn't it just keep going through the rest of the stuff? Well, the reason you had break after each case is because of this. Say you had 16 and you wanted to test it. We know that whenever it ran, it printed out, hey, you can drive now, and that's because we tested age, and age is equal to 16. So in our first case, it say, hey, this is a match. Let's go ahead and run this bit of code right here. So since we got a match in our first case, there's no need to test this one, and we're not going to run the default because this is the only one we want to run right here. So what break says is break this switch. It pretty much saves your program the trouble of having to run through the rest of these cases because it's not going to be useful to run through the rest of them as soon as you found a match. So let's go ahead and say we had 18 in there. What we would do is it runs it and it prints out, go buy some lotto tickets. Since we have that break in there, it did this. Alright, in the case of 16, nope, you're 18. In the case of 18, bingo, we have a match. So let's go ahead and print out go buy some lotto tickets and break out of this loop. So no need to test 21 and no need to use the default. Since we broke out of it, we found our match. So again, what break does is it basically saves you from going through the rest of the loop. And why do I not have one at the end of default? Because by the time we get to the end of default, it's at the end of the switch anyways, so why would you need to break out of it if you're just going to exit out of it after the default anyways? So that is basically a switch statement. It basically takes a variable and tests the value against each one of its cases. 16, 18, 21. If it isn't any of those values, it runs the default. Now I have 3 cases in this example, but you can have 1, you can have 1,000, you can have 1,000,000 if you want. And yeah, that's all. So anyways, that is how a switch works, and that is what break is. And I just want to mention one more thing before I let you guys go. Break, I'm using it in this example of a switch, but it's a keyword that we're going to be coming across a lot in C++ programming, not only with switch. So whenever you see it later on, whenever we're doing, just regular loops or something, I just want to let you guys know it isn't only limited to the switch statement. We can actually use this all throughout C++. So whenever we come across it, they'll be like, hey, isn't a switch supposed to go around that? Because we're not. So for now, thank you guys for watching. Understand the switch, and once you do, you're ready to move on to my next video. So like I said, thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video. What is going on, guys? It's Bucky, and welcome to your 26th tutorial in C++. In this tutorial, I'm going to be talking to you guys about something called logical operators. Now, let me go ahead and build a simple program right now. Say we were the owner of a nightclub, and we wanted to calculate whether a person was allowed in or whether they weren't. So first we looked at their age, and we're going to make sure it's, over 21. Because we don't want to get sued. And the next thing we're going to be looking at is how much money they have, because we don't want to allow poor people into our, 5-star nightclub. So let's say they need more than $500. So let's go ahead and make this like person has $650. So we can test this like this. If age is greater than 21 and if money is greater than what I say 500, where would I just hit insert? Where the heck's my insert key on this keyboard? This keyboard is really messed up now that I look about it. So That took me like 5 minutes to find the insert. It was actually by my up and down arrows. That's weird. So anyways, now that we had our nice little break, we can go ahead and just write something like C out, you are allowed in, and make sure you spell it with a 9 in U, and make sure you spell in ion, or else this program just won't work. So let's go ahead and run this and see what we get. We are allowed in because we indeed are greater than 21, and we have more than $500. So you're saying, alright, pretty cool program. Maybe I'll open up a nightclub now, but check this out. This can get kind of confusing after a while because this brace goes to this and this goes to this. We're pretty easily distinguishable, but what if we had 5 different tests that we need to check? What if we had 20 different tests? Well, one little mistake, say we had this over here, our program's still going to run fine, but it looks like this goes to this and this goes to main or something. Who knows where this one goes? I mean, putting a bunch of if statements inside other if statements is not always the best idea. So we have a better way to test 2 or more things, and that's through the use of something called logical operators. And this allows you to make all your tests on a single line. So here's what we can do in this case. Go ahead and make your if statement, and then might as well make our C out right now, like you are allowed in, exclamation point with an end line. And in our if statement, go ahead and write your 2 tests, like what do you put? Age is greater than 21, and whenever you join them, you use this logical operator and. And now go ahead and write money is greater than 500. Now let's go ahead and run this and check it out. Same results, a whole lot less programming. So what and means, do this test and do this test. If they're both true, then run this bit of code. And since they both were true, it ran this bit of code. If one of them was false, say we only had, $4, like that, well, yeah, this test is going to be true because we're greater than 21, but this is going to be false because $4 is not greater than 500. And whenever we run it, we are not allowed in. Check it out. And also, if both the tests are false, like we're only 2, and oops, wrong space for that. Say we're only 2 years old and we only have $4, probably from the Tooth Fairy. Of course, we are not going to be allowed in the club. Not cool, but we're a 2-year-old. Who needs to go clubbing when they're 2 anyways? So basically, a double and sign means this: test all these tests, and if they're both true, then you can run this bit of code. But if one of them is false, or both of them is false, then we don't run it. Simple enough, huh? And I say and with this test and this test, but you can also have and in another test, and even and in another test, and it's just going to run all of your tests and make sure that they're all true. So the only way this bit of code is going to run is if all your tests in this is true. So if you're saying, alright, I understand that logical operator, all the tests need to be true in order to run. But what if you say this: alright, I'm, not the most professional nightclub owner, so I'm going to allow them in if only one of these tests is true. If they're over 21, then they're allowed in, of course. Or if they have over $500, I'm going to allow them in because, if a 20-year-old walks in with like 8 grand, I know he's not 21, but I think we should let him in anyways. So say we want to do that. Make sure only one of the tests is true. What we do is use a logical operator called the OR logical operator, and that's if you see above the enter key on your keyboard and hold shift, you get these 2 little things. I call them pipes, but I think some people call them pipelines. Tell you the truth, I don't know what they're called. It's like a straight line up and down, as you can see. But that's what it is, and 2 of them in a row is the OR logical operator. And what the OR logical operator says is this: unlike the AND, where this one and this one had to be true, only one of them has to be true and the other one can be false, and it still runs the bit of code. So check this out. We passed this test as true, 26 is greater than 21, but we don't have more than $500, so this is going to be false. So true and false. So we run it, and it allows us in even though one of these was false. But if both of these were false, say we were only 6 years old, it wouldn't allow us in. So anyways, what you have to remember is this: the AND logical operator, both the tests have to be true. With the OR logical operator, one of the tests have to be true. And another thing, if both of the tests are true in an OR, it's going to run your bit of code. So let's say you were, 64 and you had, a crap load of money. It would run, and even though they're both true, it would allow you in anyway. So with the OR, this one, or this one, or both of them have to be true. And with the AND, this one and this one has to be true. And of course, you can add another OR, test, and another OR, test, and another OR, test. And when you run a program like this, it's going to run through all of your tests. And as long as one of them is true, for example, this one could be true, and all these other ones could be false, and it will still run this bit of code. An OR basically means look for at least one that's true, and if it's true, run the bit of code. So now that I repeated that about 800 times, you guys should understand the difference between an AND and an OR logical operator and when you would want to use one versus the other. I guess it depends on what kind of nightclub owner you want to be. But for now, that's all the club on I'm going to do. So thank you guys for watching this tutorial. Don't know what I'm going to cover in the next tutorial, but if you click on the next link, you can see. So thank you guys for watching, and I'll see you then. What is going on, guys? It's Bucky, and welcome back to your 27th C++ tutorial. And this tutorial is actually going to be a pretty fun one because we're going to be talking about random numbers, what they are, a couple functions that are going to help us build random number generators, and I'm actually going to teach you guys how to build a sweet random number generator. So before we get into that, we need to include a header file. So include, and the header file is called CSTDLIB from the C standard library, and we include this because we want to use a function from it called rand, not rund, rand. And what this does is whenever you call this, it basically returns to you a random number. So let's run it, and we got 41 in this case. So as you can see, whenever we print out rand, it pretty much takes a random number and gives it to you. So you're saying, wow, there you go, there's our random number generator, perfect. Well, there are actually a couple problems with rand, and we're going to be talking about those later on. But for now, I want to show you guys how to build a basic random number generator. And let's go ahead and just call rand like 25 times. So let's go ahead and make a for loop, and go ahead and make int x set equal to 1, and make x is less than 25, and of course x plus plus. So now we have a loop that's going to run 25 times or sometime around that. So now let's just go ahead and see out let's just go ahead and see out rand and see what happens. And then might as well end that line so it looks nice and pretty. Let's go ahead and print it and see what we get. Okay, so it looks like we're getting a huge list of random numbers. Alright, looks pretty good. But what if I'm going to build a random number generator and I don't want numbers quite this big in tens and thousands and stuff like that. Say we're building a random number generator to simulate people rolling dice or something. Well, I only want the numbers 1 to 6. So here's a neat little trick where you can get that result set. In order to get a certain set of numbers, go ahead and take your rand and put modulus 6. What this is going to do is it's going to give you 6 random numbers. It's going to take a big number like 25,000 or something, divide it by 6 and give you the remainder of that. So the remainder, whenever you divide by 6, can either be 0, 1, 2, 3, 4, or 5. So let's go ahead and take a look at that. Whenever you divide by 6, you're limited to only the number 0, 1, 2, 3, 4, and 5. You can't have 6 as a remainder because anything divided by 6 with 6 remainder, it would just be another 1. So you can say, alright, well, I'm trying to simulate a dice here, and they have the numbers 1 through 6, not 0 through 5. So we got 6 numbers, but we don't want 0 through 5. We want 1 through 6. So, Bucky, can you just show me how to take all these numbers and shift them, add 1 to them? Well, that is very simple. Just go ahead and surround your rand 6 and just put 1 plus. Now, what this is going to do is it's going to take a random number, divide it by 6, and whatever the remainder is, which would be 0 through 5, it would add 1 to it. So now you're getting 1 to 6. So now you can see that 0 is eliminated, and we have 6 now. So 1, 2, let me find a 3, 4, 5, and 6. So that is how you build a random number generator using, a specific result set. So remember, however many numbers you want, you put as a modulus of rand, and however many you want to shift it by, just add that many to it. But let's go ahead and take a little closer look at this random number generator. Okay, let's read these numbers. 565115. Okay, they look like, they're pretty random to me. Let's go ahead and run it again. 565115. That seems kind of familiar. Let's go ahead and run this one more time. 565115. Alright. What's going on with our random generator? We built this program perfectly, which we did. So, we use random. Alright, everything's good to go. So, what's the deal? Why did it give us the same numbers every time? Well, in order to understand this, I need to talk to you guys about computers and random numbers. Now listen very closely because this is actually pretty important. No computer random number generator is truly random. The truth is that computers are not humans. Computers have to follow a certain algorithm, a certain set of instructions, a certain pattern. So for example, whenever you go into a casino and you see those automated slot machines and it looks like people are just spinning and it's giving them random numbers, well, the truth is that it's not actually giving them truly random numbers. Those slot machines, even though they're supposed to be a random number generator, they have to follow a certain algorithm, a certain pattern. And whenever you're looking at like game shows or whenever you buy an electronic and it flashes like random lights, well, those lights are not random either. Everything in electronics that is supposed to be random is not random. It's a computer. It has to follow a complex algorithm and a complex pattern. Now, the reason that these are so complex is that's what gives the appearance that it's random to humans. We don't understand this algorithm right away. Only the computer does. So whenever we see numbers like this, 5651156, those are random numbers to us, but the computer, it's really just following a big algorithm. So if you're saying, alright, so whenever we're building games and stuff, we don't want our numbers to be predictable. So what can we do in order to change that algorithm a little bit? Well, let's go ahead and let me include another, well, I won't do this yet, but the rand function right here runs on a very complex algorithm, and I don't know what the algorithm is, and I don't think many people do, but it's basically a large function that that humans aren't meant to understand. So what C++, the developers allowed us to do, is seed a random number, and you use that in a function called srand. Now what this function does is it allows us to pass in a random number, any number we want, like 67, and now whenever we build it, we get different results. 621616. Now let's go ahead and pass in another one like 215, and now we get 41311 or whatever. So whenever we seed a random number, we throw any old random number in there, and it changes the algorithm. So now I don't even know what happens when I type in 43. I get truly random numbers. So if you're saying, alright, so let's go ahead and put 43 in there every time, and we get 44151. Okay, now let's run it again. 44151. OMG, Bucky, what are you doing? All you did is you changed the algorithm a little bit, and we didn't really make it a truly random number generator. We just gave it a different algorithm to follow. Well, alright. I'll show you guys one last trick, and in order to do this, we need to include another header file. Include, and this is called ctime. And what this does is it allows us to access the clock or the time in our computer. And now let's go ahead and pass in a function called time. And as a parameter of time, not time, go ahead and pass in 0. Now let's go ahead and run this and see what happens before I explain it. Okay, 2522. Okay, let's run it again. 4614. Sweet. And one more time. 54646. So now we have a random number generator that works perfectly. So now let me tell you guys why. We know that we can use srand to change the algorithm a little bit, but if we just threw the same number in here every time, it would just have a different algorithm but with the same results every time. So what time 0 does is time 0 calculates the seconds since like 1970 or something, And what this does is every second this value is changing. So now it might be a million seconds, now a million and one, now a million and two. People don't have access to how many seconds are, counting since 1970. So this gives the appearance that this number generator is truly random now. So this value is ever changing, and that's why every single time we run our program, we're going to get a different result. So that is how people build random number generators that are is truly random, or they're not truly random, but they're as random as we can make them. So again, what we did is, here's the algorithm. All RAND does is it runs a complex algorithm. SRAND allows us to throw a number in there to change the algorithm a little bit, and time zero counts the number of seconds, and this value is changing every single second. So that's why, since this value is changing, this whole algorithm is changing every single second, and that allows us to make a truly random number generator. So there you go. I hope you guys enjoyed this tutorial. Thank you guys for watching, and don't forget to include your header files, because you can't use this program without it. And there you go. I'll see you guys next time. What is going on, guys? Welcome to your 28th C++ tutorial, and in this tutorial, as you can see, I'm going to talk to you guys about something called default arguments. So of course we're going to be building a function that takes a couple arguments, and a default argument is basically exactly what it sounds like. You know how we can have a function to like calculate the area of something, and then the user would need to enter arguments like length and another value for width. Well, they can either enter the values explicitly, or we can have a default value already in that function. So let me go ahead and we'll build a really basic function here just to demonstrate this point. So let's go ahead and calculate the volume of just something, a box or something. And so we have three arguments, or three parameters: int length, int width, and int height. So we can go ahead and make this function right now, and well, let's actually go ahead and make this function right now. Go ahead and copy this, and under main, make sure you're not in main when you make this. Go ahead and paste it, and to calculate the volume, in case you don't know, it's just length times width times height. So now we can go ahead and call this function cout volume, and the user can enter three values like 4, 5, and 5. So this should go ahead and print out 100, because 4 times 5 is 20, 20 times 5 is 100. So the volume of this box is 100. So alright, we have, just a regular function here with three values, or three parameters that it takes, and the user goes ahead and passes in those values, and it calculates it perfectly. But in order to add default arguments or default parameters, here's what you do. In your function prototype right here, instead of just having, the variable type and a variable, you can go ahead and set these equal to something automatically, like 1. We'll just set them equal to 1 right now. So if a box is 1 by 1 by 1, we can go ahead and assume that, well, it's basically this. If the user doesn't enter any values explicitly, then it's going to use those default values of 1, 1, and 1. So whenever we call this function without any values, check it out. It gives us the value of 1, because a box 1 by 1 by 1 has a volume of 1. Now let's go ahead and say that the user enters a number like 5. Okay, so the user enters a number like 5, and it gives us the value of 5. But you're saying, alright, so does that function use that 5 for length, width, or height? Well, when a user enters one value and you have a function that has three default values, the computer is automatically going to assume that you meant 5 equals the first parameter, or 5 for length. So if we go ahead and run this again, we get 5. That's because it's 5 by 1 by 1. So if you go ahead and enter something like 5 and 6, the user's automatically gonna, the computer is gonna assume that you meant 5 for length, 6 for width, and by default height was 1. So the only thing you're really overwriting is length and width. So it's basically, the rule is this: you can have a function that has default values, and by default it's going to use those values unless the user overwrites it with values of its own. Whenever the user does overwrite it with values of its own, it's going to pass them in order of which it received them. So if it passes in one number, it's going to replace the default value for that number. If you pass it in two numbers, it's going to replace the second value for that number right there. And if you just pass it in two numbers, it's going to, of course, keep that same default value of 1 for the last one. So you get 30 for your value. So, of course, I just want to point out that you can, go ahead and add 3 values if you want. But, what's the point of having default values if you're just going to have 3 parameters you're going to pass in anyways? So basically that is how you have a function that uses default arguments, in other words default parameters. And one other thing that people typically mess up, you only have to put the default value in your function prototype right here. Whenever you create the function and the function body itself down here, you don't put the values down here because you already saying, alright, if I don't explicitly pass in any values, I want to use these as defaults. So you don't need to retype it right here. So people get this wrong a lot. So don't forget to just remember that simple rule. So now you understand the basics of having default values in your function, why they are useful, and how you can pass in a different number of functions like 6 or 6 and 5 or 6 and 5 and 7, and it would all work fine. Basically, whatever you pass in, it replaces the rest with the default values. So that's all I have for you guys for this tutorial. Hopefully you understand. If you don't, just go ahead and ask me one of the questions on my forum, thenewboston.com/forum, and I will be more than happy to answer it for you guys. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next tutorial. What is going on, guys? It's Bucky, and welcome to your 29th C++ tutorial. And in this tutorial, I'm going to be talking to you guys about something called scope. I can't remember if I talked to you guys about scope already, but I need to talk to you guys about it again anyways. So anyways, I'm going to be talking to you guys about scope, not the mouthwash, a little bit different, and also something called the unary scope resolution operator. But I call it the colon because, whenever we're typing it, it's just a colon. So let's go ahead and first, let me build another function aside from main. I'm just going to build another function called Bucky. And all this is going to do is, well, we won't even have it do anything yet. So right now we have two functions, main and Bucky. They're both good to go. So sometimes people build variables inside a function like int x and set it equal to 10. Well, let's go ahead and make some interesting variables. I'm tired of x. So int tuna and set it equal to 69. Now let's go ahead and build another variable called tuna and set it equal to 20. Well, I just want to demonstrate one thing. Some people declare variables outside functions, and some people declare variables inside functions. Now, it's not just like some people have blue eyes, some people have brown eyes. They're people nonetheless, and it doesn't really matter what eye color they have. Well, actually, this does matter. It's not a personal preference. It actually does matter in your computer program where you declare or make your variable. Whenever you make your variable outside the functions, then every single function can access this tuna variable. So this function can use it, Bucky can use it. Every function has access to this variable. But for example, say you only made your variable inside one function, so you only made this variable inside main. That means that whenever Bucky tried to use the variable tuna, it's going to get an error message. So check it out. It says, tuna, what the heck is tuna? Because main functions are basically greedy. Whenever they create a variable, they're the only ones with access to that variable. So that's why people typically like to use variables and declare them outside all of the functions, because whenever you make a variable outside the function, then every single function in your program is going to have access to that. So say for example, main wanted to print out tuna and Bucky wanted to print out tuna. Well, you can go ahead and run this program right now and check it out. Both programs are going to print out tuna just fine. So the reason Bucky didn't print it out and you only saw tuna once was because we didn't call it anywhere. But anyways, that's what the scope of variables is. Basically, where you create variables depends where you can use them. So if you declare a variable in here, only main can use it. If you make one in here, only Bucky can use it. If you declare outside, both the functions can use it. But now we come across a little bit of a conundrum, and let's go ahead and delete Bucky for the rest of this tutorial because he was just an example. A dang fine one, but hey, he was an example. What if a user did something stupid like this? They made a variable called tuna outside main, so of course main has access to it, but they made another variable called tuna that's inside main as well. So main can access that one too. So now when you try to print out tuna, it has a choice. Do I use this one or do I use this one? Well, let's go ahead and print this out and see what happens. It chose 20. And why did it do that? Well, computers pretty much take the most recent or most inner variable that they can. They say, alright, here is a variable that I can use, but why use that one when I have one right inside my function? I'm going to assume that since this one was built right inside my function, that that's the one you want me to use. So these are called local variables and these are called global variables. And when it has the choice, it's always going to choose that local variable. So you're saying, alright, let's go ahead and say that I'm building a function just like this, and I want to call both of these variables tuna, but I actually want to use this variable tuna out here. Well, how do I tell my program that, alright, I know you have a local variable called tuna, but I want you to use this one? Well, in order to do that, you need to use something called the unary scope resolution operator. In other words, the colon colon. Colon colon tells your program, alright, you have two functions called tuna. One of them is local and one of them is global. Whenever you have this colon colon before tuna, that means use the global tuna. In other words, use the tuna outside your function. So now whenever you run the program, check it out. It uses that global tuna instead of the local tuna. And the reason people actually do this is because when they have variables with the same name of different data types, that's when it comes in handy. So for example, if you had an int tuna and a double tuna and you ran it, it would use the double tuna, which is 20. But if you use that colon colon, which is called, again, the unary scope resolution operator if you're taking a test or something, then it uses a 69. So I just don't want to show you guys if you're stupid and put int twice. People typically write variables with the same name whenever they're using different data types. So just wanted to point that out. So what to take away from this tutorial: whenever you create a variable inside a function, you can only use that variable inside the function where you created it. You can't use it inside any other function. Whenever you create a variable outside a function, you can use it in any function in your entire program. So if we had another function called Bucky and another one called Tony and another one called Jessica, we can use this tuna in all of those functions. So that's why you can decide whether it makes this outside or inside your function. And the last thing I want you guys to remember from this tutorial: whenever you have two variables with the same name, one is local and one is global, and you want to use the global variable in your function, you need to use this dot dot or colon colon unary resolution operator, whatever the heck you want to call it. It's two colons before your variable, and that tells C++, hey C++, I know I have a variable in here, but I want to use this one, the global variable, instead. And if you remember these three rules, you'll be good to go. So that's all I have for you guys for this tutorial. Again, basically a really easy tutorial, just a little weird concept that you have to understand. So thank you guys for watching. Don't forget to subscribe, and I will see you guys in the next video. What is going on, guys? Welcome to your 30th C++ tutorial. 30 tutorials, that's like a milestone or something. And in this tutorial, I'm going to be talking to you guys about function overloading, what it is, why it's useful, and when you would use it. So let's go ahead and say we wanted to build a function to, I don't know, maybe we wanted to have the user input a number and we just wanted to print it out on the screen. Really stupid function, but really simple. So let's go ahead and make two variables. We'll make an integer variable a, and we'll set this equal to, 54. And we'll make another float variable, and remember, a float is basically a number with a decimal point, so we'll use like 32.4 yada yada, something stupid. So now we have two different types of numbers, an integer and a float. Well, we have a function that we are going to build called print number, So let's go ahead and call this function, and again, we didn't build this yet, so if you're looking, where did print number come from? We'll build it in a second. So we're going to go ahead and try to use this function for both of these variables, print number A, and we're going to try and print out B too. So then we say, alright, now we're going to go ahead and build this function to print out a number. So we go up here, it's not going to return anything, so it's just going to be void. Of course, it's named print number. And then we get to this part right here. Alright, let's go ahead and think for a second. If we go ahead and put int x, then we're going to allow it to pass in an integer, so this is going to work, but this isn't going to work. So I know what I'll do. I'll just put float x. Well, then this is going to allow me to pass in this number, but then this number isn't going to work. So how do we solve this little puzzle right here? Well, we do this through the use of something called function overloading. And function overloading is the idea that in C++ you can build more than one function with the same name. In this case, we're going to be building two functions called print number that take different types of data depending on what you pass in. For example, we're going to build a print number right here that takes an integer value, and just go ahead and see out I am printing an integer, and then go ahead and print out the integer x, and then end that line. Well, that goes ahead and takes care of the integers that the user might enter, and now we can build another function with the same name, which is print number. Again, if you double click it, you'll see the exact same name. The only difference is it takes a different type of parameter. This one takes a float number instead. So now, whenever we call this method and it has an integer, it's going to use this one. And whenever we call this method, and by method I mean function. Sorry I keep switching on and off, but I teach too many program languages to keep it straight. So whenever it calls a function with a float, it's going to use this one. It's smart enough to automatically know what type of data you're passing it in. So this one is going to print out cout. Now I am printing a float, which is x, and end line. So as you can see, these functions are basically identical. It just runs pretty much whatever type of data you pass in. It looks for whatever function is appropriate for that type of data, and it uses that function. So let's go ahead and build and run this and check out what we get. At first, we passed in an integer, 54, so that's why I used this one that took an integer, and it said I am printing an integer. And after that, we passed in the same function, a float, which was 32.4, so that's why it chose this one. Now I am printing a float, 32.4. So as you can see, function overloading solves the problem of having one function. So check this out. Instead of trying to explain to our boss that they need to use a bunch of different functions depending on what type of data, we can make them happy and say, alright, anytime you want to use a function, just go ahead and use this print number function and put in any number you want. This is going to be behind the scenes stuff that they don't have to worry about. They don't know that we had to make two different functions just because they were annoying and they couldn't understand that they needed to work with different types of data. So we're going to make it really easy for the user through the use of function overloading. Now, whenever the user enters a number like 54, we already have a customized function that is smart enough to realize that they are entering an integer and prints out that value. But if another user, like user B, enters a float, then we of course can handle that too, because our program knows it's smart enough to realize that we're passing it in a float, so that's why it chooses this. So basically, whenever you use a function, your computer program is going to do this. It's going to look for a function with that name, a print number. If it has more than one choice, then it looks what type of data are you passing it in. Well, if I pass it in a float, it's going to look at this one. Does this print number take a float? Nope, it takes an integer. Does this print number take a float? Yes, it does. So I'm going to use this one right here. So that's why whenever you create a function, you need to write the name and also the type of data that you're passing in. So then whenever the user tries to use it, it knows what function to use. So that is basically all function overloading is. It's basically making programs that are really simple for the user, even though they might take us a little bit of extra coding. Hey, when we want to build software and we want to sell it for $1 million, we're going to want to make sure that it's easiest for the user to use as possible. Because, I mean, when we become a millionaire, this extra function is not going to be a real big problem for us. So that is how you make $1 million, and also that is the basics of function overloading. Basically, many functions with the same name, just different data types. So thank you guys for watching. Don't forget to subscribe, and I don't know what I'm going to be teaching in the next tutorial, but I got a feeling you guys definitely want to check it out. So again, thank you. Don't forget to sub, and I'll see you in the next video. What is going on, guys? It's Bucky, and welcome to your 31st tutorial. And in this tutorial, I'm going to be talking about something that every single computer science student on Earth just absolutely hates, and that is called recursion. Now, this is a topic that's somewhat confusing, but I'm going to try to make it really simple for you guys. So, what recursion is the idea that a function can call itself. Pretty weird, huh? So you know how like in main we could call another function called Bucky and Bucky would print something out on the screen? Well, recursion is the idea that Bucky could call Bucky. That's interesting. So let's go ahead and take a look at this right now. Say we had a function called Bucky, and all it did was print something out on the screen like cout, let's print out something stupid, OMG, WTF, BBQ, oh my god, WTF, barbecue. And then it went ahead and it called the function again. So now you'd say, alright, well, isn't this function gonna go ahead and we're gonna run main first, and main's gonna say, okay, go ahead and run Bucky, and Bucky's gonna say, okay, print this out and then run Bucky. Okay, Bucky, print this out and then run Bucky again. Print this out, run Bucky. Print it out, run Bucky. And whenever we go ahead and run it, we can see that this is a function that basically never ends. It prints out, oh my god, WTF barbecue, until, check it out, Watermelon EXE. My computer just crashed and gave up on this. So I'm like, alright, so what's the point of using recursive functions other than don't use them? Because, you know, first of all, if you build a recursive function like this, your computer is going to crash just like mine has, and it's not the most useful way to go about things. So one reason that people use recursive functions is, first of all, let me mention this. Whenever you build a truly perfect recursive function, you need to have something called a base case. Now, a base case is pretty much an ending point for your function. So one example that I'm going to be showing you guys is how to calculate factorials. Now, if you remember from math class, factorials are pretty much when you say 5 factorial, and it's written like this, 5 exclamation point. This is pretty much the same as saying 5 times 4 times 3 times 2 times 1. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Whatever factorial it is just whatever number times all the way to 1. So then the value of like 5 factorial is 120. The value of 3 factorial is 3 times 2 times 1, which is 6. So let's go ahead and write a program to do that, and this is one of the instances where recursion is actually a good idea. So let's go ahead and make a function called, we'll call it factorial find. So int, first of all, better spell that right, int, factorial finder, I think I spelled that right, and it's going to take a parameter, which is int x. Can I not spell int today? Int x. And the parameter it takes is what value do we want to find the factorial of. So if we passed it in 5, hopefully it would give us 120. If we passed it in 3, it would give us 6, so on and so forth. So the first thing we need to build is something called a base case. Without a base case, this factorial finder would never end. Just like Bucky, you know how it ran forever until my computer crashed? This is what this is going to do if we don't give it a base case. So we need to say, okay, if x is indeed equal to 1, then we want to go ahead and return 1. So whenever you return something, remember your function ends, and that's the point that we're trying to get to. So in order to do this, we're going to assume that they're going to be passing in numbers other than 1. So we're going to go ahead and do this. Else, if they pass in a number aside from 1, like 5 or 3 or 20 or something like that, go ahead and return the value of x, which is, 5, 3, 20, and then go ahead and multiply that by factorial finder x minus 1. So what it's going to do is, yeah, it's going to call the same function again, but it's going to call it with a different value. It's going to call it with 1 less than before. So if you go ahead and you pass in 5 to this function, what it's going to do is say, alright, I'm going to call 5 times the 4 factorial, or factorial 4. I don't even know how to say it. I'm not a mathematician. But anyways, what it's going to do is it's going to say this. I'm going to call 5 factorial 4. Well, what's the value of that? I don't know. The value of that is 4 factorial 3. What's the value of that? I don't know. 3 factorial 2. What's the value of that? I don't know. 2 factorial 1. What's the value of that? I don't know. Oh, wait. I do know. 1 factorial is 1. So now that it has that bit of information, it can go ahead and solve the rest of the questions that it asks. You know how I said, I don't know, I don't know. Well, now it can say, alright, Bucky, 1 factorial is 1, so now I know that 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, and 5 factorial is 120. So that way, you can see that whenever we go ahead and run this, factorial finder, there we go, I didn't feel like printing out the whole thing. That way, when you print out factorial finder 5, and let me just go ahead and end that line, and we run this program, it says 120. Yeah, it was 120, but there is a lot of stuff going on behind the scenes that the user didn't have to see. What it did is said, alright, it ran this function like 5 different times searching for 5 factorial, and then it called it again searching for 4 factorial, then did again searching for 3, 2, and finally when it got to 1, it could answer all the rest of those questions. So this is how you can use recursive functions in a useful way. Again, a recursive function is just using the function inside the function body itself. And remember, whenever you do this, you need to have a base case. You need to have an ending point that actually answers that question. So in this case, whenever they got to 1, it could solve the rest of its questions, because if we didn't have that base case, like before when we printed out OMG WTF barbecue, it would just run forever and ever and ever without an end. So that's why you need to give it a base case, in other words, a point to get to, where if it solves that question, then all the rest of the questions can be solved. So again, you guys can probably see why people hate recursive functions, but why sometimes you actually need it, because there's a lot of stuff going on behind the scenes that we don't get to look at, but we just have to, assume in theory that this is going to work. So it's a little bit different than regular programming in the fact that you don't explicitly call a function like this, that a function is going to call a function for you however many times it needs to. So there's a lot of theoretical programming that you need to think of, and a lot of different things that can go wrong with recursive functions. So that's why I wanted to show you guys a quick example of the bad way to use recursive functions and the useful way to use recursive functions. But now that I taught you guys that tutorial, we can finally, get over recursive functions. You will be happy to know that I don't use recursive functions a lot in programming, and we're probably going to be, done dealing with them for a while. But, it was a topic that we definitely couldn't skip, and now that you watched this tutorial, I'm glad I taught it to you guys. So thank you guys for watching. Don't forget to subscribe, and don't forget to put a base case in your recursive functions, or else your guys' computer is going to crash. So thank you guys. Don't forget to subscribe, and I'll see you in the next video. What is going on, guys? Welcome to your 30-second C++ tutorial, and in this tutorial, I am super excited because I'm going to begin talking to you guys about something called an array. So an array is basically one of my favorite parts of C++ because an array is basically a variable that can store multiple values, and you can do a bunch of cool things with them. And like I said, it's one of my favorite parts dealing with C++. So let's go ahead and get started.